TypeScript is a superset of JavaScript programming language that adds the concept of static typing to the core feature of JavaScript. This is a big deal because JavaScript is and always has been a dynamic language. In order to illustrate why this is such a big deal, I will quickly define what it means to be a static language or a dynamic language, and how they seem at first to be completely opposite. Both dynamic and static languages rely on type. That is, definition of data structure and their behaviors to ensure that programs are correct. It's just that the two kinds of languages validate that in a different way. Dynamic language aims to be more forgiving at development time, relying on the concept of duck typing to validate that a particular object can be used in a certain way. Duck typing refers to the idea that if it looks like a duck, walks like a duck, quacks like a duck, well, it must be a duck. In other words, if my code expects an object that has a method called quack on it, and I get an object that has a method named quack, well, that sounds good for me. I don't need to validate anything else about that object. The net result of this approach is that tools don't have information to catch errors before the application runs. For example, if I have accidentally typed the wrong name quack rather than quack, this means that the error are only ever caught while application is running after it's too late to do anything about it. So, statically typed languages, on the other hand, are much more rigid. They aim to catch development errors before the code is even executed. And they do this by imposing restriction on how you can interact with objects, forcing you clearly specify everything about the object that you're going to interact with. In the static typing world, you can't just call a quack method on any object. You will first need to explicitly define a type that has a quack method as well as any parameter that needs to be passed into a method. Not to mention the value that the quack method will return to its caller. Only that you can use instance as a parameter or create an instance of that class to pass around to other objects or methods. With all this information explicitly provided, the tooling is able to easily tell when I have misspelled a call to a quack method well before my application is running. It's likely to take less than a second for me to find out that I have done something wrong. If it sounds like I'm making a case for one approach to other, I'm not. Each of the typing approaches lends itself to a different set of scenarios. So it's quite simple, depends on what you're looking to do with languages. But here's the thing, who's to say you can't use both at the same time, for better or worse? JavaScript is a dynamic type language that makes it particularly suitable for dealing with the web browser object model that was originally devised to work with. But JavaScript has been asked to do far more these days than what it was originally designed for. And in those cases, some people start to find its dynamic nature more of a curse than a gift. So in these scenarios, being able to apply static typing, you can have a hugely beneficial effect on the stability and maintainability of your code. Well, that was a quick introduction to TypeScript. From the next video onwards, we are going to start our adventure with TypeScript. Welcome back. Before I get too deep in TypeScript, I want to take a moment and set some expectation. TypeScript is a superset of JavaScript, which means that it is an extension of JavaScript, adding new features and syntax on the top of a core language. In this course, I'm going to focus on the unique features that TypeScript adds to the language, rather than explaining the fundamental of JavaScript itself. And I'll be depending on the assumption that you've already got some decent familiarity with the JavaScript language, to the point where you would be able to pretty easily recognize where JavaScript ends and TypeScript starts. In other words, if you are comfortable using JavaScript to enhance a website, to make an AJAX call and update parts of the website when a user clicks on a button, then you will be just fine following along with me in the adventure of a TypeScript. And also, if you have no idea what JavaScript is and you are interested in JavaScript because you want to become a web developer, then I got you covered. I've got a full stack JavaScript course on Udemy, which basically you can look for. It is about 17 hours long and it got everything you need to up and running with JavaScript building dynamic web applications. Welcome back. In this video, I'm going to talk a little bit about the tools you will need in order to work with TypeScript. Actually, I don't need an entire video to explain which IDE or which text editor is better or bad. The answer is very simple. Since TypeScript is just a superset of JavaScript, you will almost certainly end up using the same tool to work with TypeScript as you already use to work with JavaScript today. TypeScript is a compiled or transpiled language, so you will need at least two tools to work with TypeScript, a text editor and a TypeScript compiler. Now, technically speaking, you can use any text editor you want. However, you're probably going to want an editor that understands TypeScript well enough to offer some nice features such as syntax highlighting and autocomplete functionality built right in. Lucky for us, TypeScript has been around long enough and gained enough popularity that your favorite JavaScript editor almost certainly has some kind of TypeScript support, either built in or maybe available as an extension. For the most of the popular text editors such as Sublime Text, TextMate, Atom, Notepad++, Visual Studio Code, it's as simple as searching in their library for extension and installing the TypeScript feature. And then of course there are full-fledged integrated development environment IDEs such as Visual Studio or WebStorm or Eclipse. Just like the basic text editor, your favorite IDE will likely have a great support for TypeScript, but some of them may even have that TypeScript compiler built right in. In the following videos, I'm going to show you a couple of ways installing TypeScript to make sure that one of them will be good fit for you. So the question you might be having, which IDE we're going to be using throughout this course? Well, my personal preference is WebStorm, which is not a free IDE. But don't worry, we're going to be learning how we can set up TypeScript in a free Visual Studio Code text editor. No matter what text editor you use, you're going to be able to follow along with this course just fine, because writing a code is just writing a code. It doesn't really matter what IDE or what text editor you're going to be using. So I'll be using WebStorm, but I'll show you in a separate video how we can set up a project, TypeScript project in Visual Studio Code. Welcome back everybody. In this video, we are going to set up TypeScript command line tool, and also I'm going to be introducing to you a few of the things we need to start developing TypeScript application. So right now I am at typescriptlang.org website, which is the official website for TypeScript. We're going to be using TypeScript 2.7, which is the latest version of TypeScript. And also I want to show you how you can install TypeScript on Windows and Mac and Linux as well. So the process of installing TypeScript is pretty much similar on all operating systems. So we use a Node package manager to install TypeScript. I'm going to take you to Node.js website first. So this is the website nodejs.org. And if you open this website, you will come to this page. And here you need to install Node.js first. So we have two versions here. So 8.9.4, it's a long supported version. 9.5.0 is a current version. So it doesn't really matter which version of Node you download and install. So to download and install, you simply click on that. Right now I am on a Mac, that's why I'm seeing a Mac version here. But if you're using Windows or Linux, you will see the Linux and Windows version here. So basically I'm just gonna click on that and it's gonna start downloading Node.js. Here you can see I've already installed Node.js, so that's why I'm just gonna cancel that out. And to check whether you have a Node.js installed in your system or not, you can open terminal. So I'm just gonna open a terminal here. On a Mac, we have a terminal. And if you're on a Windows, you can open CMD, command prompt, or you can use the Windows latest PowerShell as well. So click on the start menu and then type PowerShell and you will see Windows PowerShell there. Just open it up and here you want to type the command node space -- version. Press enter, and here I can see I have installed successfully version 8.9.0. So once you install Node.js, you install npm automatically. So here if I type npm space dash dash version and press enter, and I can see I have a Node package manager installed in my Mac with the version of 5.5.1. So we are ready to install TypeScript now. So how do we install TypeScript? So let's go and write a command, which is a Node package manager command. So we'll type npm install -g and type TypeScript. Press enter, and now it is going to basically give you an error if you are on the Mac. Basically, it's saying that the permission to write to user local lib node modules on this path is not permitted. So if you're on a Mac or Linux, you need to type sudo npm install space -g and then TypeScript and press enter. And here it's going to ask you for the password. You type your password in there, and once you type your password, it's going to start installing TypeScript. So here it says TypeScript 2.7.1 added one package. Now TypeScript has been installed successfully. How we can verify that? I'm going to type the command on a terminal tsc. I'm going to press enter, and I'll see all of these texts in my terminal, which basically telling me that TypeScript has been installed successfully, or now we can build TypeScript applications. So I'm going to close the terminal, and we'll go and have a look at the TypeScript website, which is basically typescriptinglang.org, which is an official website for that. I'm going to take you to the documentation. Every time you learn a new programming language, you got to go to its documentation to enhance your knowledge about the particular technology. So during this course, we are going to take a look at documentation very oftenly. So this is a documentation page, and also we are going to take a look at the Visual Studio Code, which is a free IDE which can be used to build TypeScript applications. So here, code.visualstudio.com. Here you can download for a Mac or Windows, or even it's available for Linux. So this is a great free choice for writing a TypeScript application. It has a support for that. So basically you will go and download it, install your PC, and you will be ready to go. Let's take a look at another IDE, which is my favorite choice, but unfortunately it is not free. It costs about $59 US, and this is the IDE we're going to be using throughout this course. But don't worry at all. If you want to use free version, Visual Studio Code will do the job. A lot of professional developers still use Visual Studio Code, even though it's free. It has a strong support as well. So you won't feel like I'm using some advanced features which are not available in Visual Studio Code. At the end of the day, it is just a text editor. You can pretty much start typing your TypeScript code in Notepad or in text editor in Mac. So we don't really need these IDEs, but these IDEs provide the functionality such as syntax highlighting or code completion. Both of the IDE will do the job. They're pretty good, so you won't feel like you're missing out. Welcome back. In this video, we are going to do a few things. First of all, we are going to take a look at Visual Studio Code and some of its features, such as extensions, how to create a project, how to create a file, terminal in Visual Studio Code, and so on. And after that, we will learn how we can compile a TypeScript file into a JavaScript file so we can run it on the browser. And I'll show you how you can use a tsconfig.json file to configure some settings for TypeScript. So let's get started. Well, first of all, I welcome you to Visual Studio Code. When you start your Visual Studio Code, this is the page you see. It's called a welcome page. At the left, you see we have some options. We have Explorer, we have Search, we have Debug Mode, we have a source control, and we have extensions. Now in Explorer, you can see all your files of your project, but we are not seeing any files right now. The reason why is because we have not created a project in Visual Studio Code or we haven't opened any project in Visual Studio Code. So how do we create a project in Visual Studio Code? It is very simple. You just have to create a folder, open that folder in Visual Studio Code, and all the files available in that folder will be visible in Explorer. So there are a few ways to create a folder on a Mac, on a Windows, on Linux. So the simplest way is to go to where you want to create a folder. So I have created this TypeScript folder, and inside this folder, I'm going to right click and I'm going to click on new folder, and I will just say TypeScript code, right? Now I'm going to navigate to this folder and open that folder in Visual Studio Code. So it's very simple. We just click on open folder and we navigate to TypeScript folder and click on open. So once you click on open, you see that something is changed in Explorer. Now we can see we are in TypeScript code folder and we have these 4 buttons. Let me tell you these buttons do. Here we can click on this button to create a new file. We can click on this button to create a new folder. We can refresh the project structure. We can collapse all the files of folders. So this is a quick introduction how you can create a folder, open the folder in TypeScript. Well, if you're on a Windows or Linux, the process will be very similar. Simply go to your File Explorer, create a folder, and then here click on Open Folder, or you can go to File menu and click on Open. And navigate to that folder, double click on it. Let's click on open and that will be opened here. So the next option we're going to look at is a search. Now here you can search throughout your project. Next we have a source control. I'm not going to talk about this at the moment. We'll look at this later if we need to. We have a debug mode. We have extensions as well. Now extensions are important. I want to point out some cool extensions that you can use in Visual Studio Code which will help you to write your code faster. So first extension I want to point out is a live server. So when you're writing your web application, you want to make sure you run that on a server instead of just opening the index.html files. So you click on live server and here you can see we have installed live server. So how do we install extension to Visual Studio Code? Pretty similar. You go to this input field and type the name of the extension you want to search for. So let's type live server, press enter. And here the first one is the one I have installed in Visual Studio Code. So you just click on that and you will see install button here. Click on that and then you have to reload Visual Studio Code. The next extension I want to point out is pretty cool. It's HTML snippets. Basically, you can write your HTML very quickly by using this HTML snippet extension, which I'm going to give you a demo in a second. Next, we have a JS, CSS, HTML formatter extension, which is another cool extension, which will help you to beautify and indent your code very easily. So whenever you save the file, whenever you save your files in your project, it will automatically indent that, which is really cool. The next one, you want to install an external terminal here. Now, the terminal we're going to be using or you're going to be using is built into Visual Studio Code. So you don't really have to install external terminal, but if you want to have a bit fancy external, then you can go and search for a terminal and install the one you like. We have a VS Code icons, which are really cool as well. And if you download the latest version of VS Code, that will be installed automatically. So what it does basically, when you create a file in Visual Studio Code, it will have an icon just before the file name, which basically looks cool, but not required. So these are the few extensions I have installed in Visual Studio Code. You can check them out as well. If you like some themes, you can check out Dracula theme, which is pretty cool as well. All right, so let's go back to Explorer. And now here we are going to close the terminal first by clicking on this cross button. And now let's go and create a new file. So there's multiple ways that you can create a file in Visual Studio Code. Right click, there's an option for new file, file menu, new file. And the shortcut key is Command N on a Mac and Control N on the Windows. Now we have these buttons. I'm going to use these. So I'm going to click on this new file button And first of all, let's create an HTML file, and I'm going to name it index.html. Press enter. Now we have an empty index.html file. Let's create a TypeScript file as well. Now TypeScript file has an extension of TS. We know that JavaScript file has an extension for .js, so TypeScript has .ts. I'm going to click on new file and I'm going to say app.ts. Press enter. We have a TypeScript file. Let's go to index.html file, and here I will write some HTML boilerplate code by using HTML snippet extension. So instead of just starting with less than equal to sign, I am actually going to just start typing HTML, which gives me these options. I'm going to select the second one, HTML5, and I'm going to press enter, and that will write a boilerplate code for me. I could write this code by myself, but that's the benefit of having some extension installed in Visual Studio Code. So here, let's change this to, let's just say TypeScript course. Right, I'm gonna save the file, and now as you can see, it automatically indented that file. This is because we have installed this Beautify extension, which is another cool extension. This is the one, Beautify. So let's go back to Explorer. Now we're going to go to TypeScript file, and here I am going to write a simple variable code, which is going to be a TypeScript code. But don't worry if it doesn't make sense. We're going to start from scratch from the next chapter, next section of this course. I'm just going to show you how you can compile TypeScript files into a JavaScript file, because you cannot run TypeScript file directly on the browser. You need to convert or compile that TS file to .js file. How do we do that? First, let's type some code. I'm going to type let. I'll make it a bit bigger here, so that would be easier to look at. So I'm going to say let, and I'll say hello, colon, and the type of the variable, which is string, is equal to, I want to say hello everybody, welcome to TypeScript course. Right, now this is a TypeScript. I'm going to save the file. Now how do we compile this to a JavaScript file? Let's go and open the terminal. Well, if you're on a Windows, you can open Windows PowerShell, or you can use the command prompt as well. That will do this, that will do the job. Right, so now here I'm going to click on terminal, and here I want to click on ls first. Not click on, type ls, press enter. That will show you which directory are you in and how many files you have. So as you can see here, I have two files, app.ts and index.html file. Now, first of all, let's try compiling app.ts file into a JavaScript file. How do we do that? Remember, I've shown you a command, tsc. If I type tsc, it gives me a lot of options here. Now, we have a lot of parameters we can use as well, which we'll look at later in the course. But for now, I want to point out this parameter called -w. Now, let's go back by typing clear on the terminal and just clear up the terminal. Let's compile this file. So I'll say tsc, and I'll say /app.ts. Now tsc is going to be used as a compiler command, and then we're going to point out which file you want to compile. So here we say /, which basically navigates to the current directory, and the name of the file, which is app.ts. I'm going to press enter. Once I press enter, as you can see in the Explorer, we have another file now, app.js file. Let's open that up. And now as you can see that we wrote this string in a TypeScript language, and it's been converted into a plain JavaScript by using a var keyword hello as a variable name and the value of our string. So we have successfully compiled the TS file into JS file. Now, if let's say you have 100 TS files and you want to compile all of them, that would be a lot of pain to do that. So if you will have to do an tsc dash // and then file name, that will take you ages. So how do we compile how we can make this process automatic and make the TypeScript compiler to look for the changes in the TypeScript and automatically compile those files into a JavaScript file. Now I'm going to go and type TSC again and press enter. I'm going to take you up, and here we have a flag -w. Basically what it does, it watches for input files. Let's use that. I'm going to clear the console by typing clear on the terminal. And now let's go and type TSE space and then use that flag by typing -w space // and the file name app.ts. Press enter. Now it says that starting compilation in a watch mode. Well, what does that mean? That means that TypeScript compiler is constantly looking at app.ts file. So if we make any changes, it's going to compile that file automatically for us. Now I'm going to show you the app.js file. As you can see, we have just this code at the moment. I'm going to take you back to app.ts file. Let's define another variable. Let's say name, and that would be string, and I'll say Awais Mirza, my name. I'm going to save the file, and once I save the file, as you see on the terminal, it says compilation complete, watch for file changes. So if I go to app.js, and now as you can see, I have another variable name and the value of the string I type. So it's been compiled automatically. Now it's basically looking for the changes in app.ts and will compile that file into app.js file. So how cool is that? But still, we have a lot of flags in TSC. So let's just stop this process by pressing Ctrl+C on the terminal. We type TSC. Now we have a lot of options which we have to talk about throughout this course, but would you be able to, start typing all of these flags one by one? Or you want to have a better solution so you don't have to go to the terminal and basically start typing all of these files and all of these flags again and again. That's very tedious, right? So there's a better way to do it by using a tsconfig.json file. Now we're going to go to Explorer, and I'm going to say new file, and I'm going to click on new file and say tsconfig.json file. Press enter. And now we have successfully created a JSON file which will have all the configuration related to TypeScript. Now here we have a lot of things that we can use. So let's start by defining an object. I'm going to use this code block. And first key I want to type here, compiler options. I'm going to press enter, and I'm going to say, okay, how many compiler options do I have? So if I type Ctrl+, as you can see, I have so many options that I can use for compiler options. Now here we want to look for a target key. We press enter, and now right now, as you can see, it says target is ES3. So what does that mean? Now ECMAScript basically has a versions of JavaScript. So the latest one is ECMAScript 6, which at the time of this recording has a full support in many of the latest browsers. For example, Chrome or Firefox or Safari, they all have pretty good support for ES6 version for JavaScript. But we want to compile our code to the older version of JavaScript, which is ES5, which has 100% support in any browser. So type ES5. All right, let's save the file. And now if we go back to terminal, and now we just clear the terminal first by typing clear command. And now I don't really have to specify whether I want to watch for this file. So I'll basically simply use TSC, and then I'll say -watch. Right, I'm going to press enter. And now it's basically going to watch for every single file available in our application. Let's go and create another TypeScript file. I'm going to create a new file by clicking here, and I'll just say second.ts. And now, as you can see, once I created second.ts file, I'll go and define, let's just say A, which is a string, and I'll say ABC, press enter, and then Command C to save the file. Once I save the file, as you can see here, we have another file, second.js. As you can see, we have successfully compiled our code into the version we defined in tsconfig. Now here, if I change this to ES6, and I'm going to save the file, and now if I go back to second.js, and now as you can see, it compiled our JavaScript file into version which is ES6. So ES6 basically introduced a new way of defining variable, which was let and const. Now as you can see, the variable is defined by using a let keyword, which shows us that this is the version we're using is the ES6 version for JavaScript. So we know how we can compile the file. We know how we can use this tsconfig.json file to basically configure our TypeScript compiler, and how we can look for multiple files and make sure that they basically get compiled automatically. Alright, so in this video, I'm going to talk a little bit about this section of the course. Now, TypeScript is built on the top of latest JavaScript features called ECMAScript 6. So we need to understand those features so we could use them using TypeScript. So this section is all dedicated to ECMAScript new features, and we're going to be learning about template string, spread operators, data structures in ES6, for off loop, and we have some coding challenges as well. Now, if you are pretty comfortable using ES6, then you can skip this section and directly jump to the next section of this course where we'll start using and exploring TypeScript. Welcome back. Now from this video onwards, and in this section, we are going to start learning ECMAScript 2015, or you can call it ECMAScript 6. We've already seen some features of ECMAScript 6, but I wanted to have a separate and complete section about ECMAS6, so we could talk more about ECMAScript 6 features and we could look at it in details. So a discussion of what ECMAScript 6 is should be started with a quick recap of a history of ECMAScript in general. In 1995, JavaScript was originally created by Brendan Ike at Netscape, and then was adopted by Microsoft as JScript. With different versions of a language for different browsers, there was soon an urgent need to standardize the language. ECMA, or you can call it European Computer Manufacturers Association, is a governing body that provides the ECMAScript specification for JavaScript browser implementation. Shortly after its foundation, the ECMAScript 1 specific was released in 1997. Following this, the release of ECMA 2 and ECMA 3 came out very quickly, and ECMA 4 was much argued about, and then was eclipsed by ECMA 5 in 2009. Now, which brought us a new array method like each, map, and filter. And as of June 2015, we now have an official specific for ECMAScript 6. So what does that mean for us as a JavaScript developer? It means that we now have a ton of new options to work with when designing our JavaScript project. So we have seen a few keywords for declaring variables, let and const. For functions, we haven't talked about it yet, but we can also use default parameter as arrow function. ECMAS6 also contains classes, template strings, and new ways of dealing with arrays and objects. We'll be talking all about this in this section of the course. Since the beginning of JavaScript, people used a var keyword to define a variable in JavaScript. Now, ECMAScript 6, let me explain to you what is the ECMAScript 6. ECMAScript is the organization which manages JavaScript features. For example, they actually launch the specification of JavaScript and then what are the newer features should be available in JavaScript. Now, in ECMAScript 2015, or you can call it ECMAScript 6, introduced two new ways to define a variable. So we have a var keyword, and now we have another keyword, const and let. Now you define a variable by typing a var keyword, a name of the variable, and the value. So you do the same thing with the const and let, but there are some things that you need to know. What are the difference between var and let and const? So that's what we're going to talk about in this video. Alright, so the first way of defining a variable we're going to look at is a const keyword. Now, let me give you a simple definition of a const keyword. You define a variable with the const keyword when you don't want its value to be changed. So that would be a constant. Constant, short for const in JavaScript. So let's say if I define a var keyword and I'll say x is equal to 50, and I'll just console.log x, and let's refresh the browser, and now here we can see 50, and if I type x here and press enter, I get 50, and I can say x is equal to 40, and now if I type x has the value of 40. Now if I change the keyword var to const, I'll save it and I refresh the browser, I get 50, and now if I type x, enter, I still have 50, and if I try to change the value of x by typing x is equal to 40, I press enter, and now I get this error. So the error says that assignment to a const variable is not possible because you're trying to assign a value to the constant variable, which value should not be changed. So if you want any variable to hold a value and it should not change, then you define a variable by using a const keyword. This is a great because when you want to define something which should not change, for example, the layout of your web app or a player ID in your game which is made in JavaScript, then you should use const. There are different scenarios that we want to look at. So what I'm going to do, I'm going to remove the code and I will create a variable with the var keyword, and I'll type name is equal to, and I will give it John. Alright, now let's take a look at the demo that what we can achieve by using a const keyword. And then after that, I will create a function. So we just name it create name, and we give two parameters. So first name, last name, right? And here I will define name is equal to first name and concatenate it with empty string, and then concatenate with the last name, right? And then I'll just do a console.log, and I'll just print out name. And outside the function, I'll console.log name variable as well. Then we need to call this function, right? So I'll just call it here. So I'll just say create name, and I give a name here, for example, Paul, and I'll just say Robert, right? I'm going to save the file and we just refresh the browser, and here we get John, and then the second console log prints out Paul Roberts. Now you want to keep the name variable with the value of John. So what if I just try to access a name variable and I can see that the Paul Robert is there, but what about John? Where is the John now? Now John is gone because this function is trying to access the name variable from the global scope, which is defined outside the function. So here we have a name, and inside the function we're accessing a name variable. Now what if I change this var keyword to const, and I save the file, and I just refresh the browser, and I can see I can print out John, but when it goes inside the function it gives me an error because you're trying to change the value of a constant, which is not possible in JavaScript. So what we can do to fix this problem, if I add const, and I'll just save it, and then I can just refresh the browser, and as you can see the error is gone. Now we have a John and we have a Paul Roberts, And here, if I check the variable name, which is defined by using a const keyword, and I press enter here, and I can see that I have the John there. So it did not get changed because now the const name defined in create name function is not trying to access the name variable on a global scope, right? So if I go and call this create name function, and I'll just create another name, which is say from Microsoft, Microsoft and Apple. Press enter, and now as you can see, I have this Microsoft and Apple. And now if I try to access the name, and I can still see that the John is there. So this is a great way to avoid changing the variable names or variable values which you don't want to change. So this is how you can fix the problem by using a const variable. Alright, so now let's talk about something complicated. The const keyword can be used with arrays and objects. Now, does that mean that once you create an object, you cannot modify it, you cannot add keys and values to it? So let's take a look at the demo as well. So I'm just going to remove this, and I'm going to create an array first. So I'll create array const is equal to days is equal to, and I'll just add an empty string with the one value, Monday. Alright, now let's say we are going to refresh the browser, and here if I try to access days, I get back a value of Monday. Now we have defined that days array with the const keyword. So are we able to modify this object, or we will be able to add some values to it? So let's try that. So if I type days dot push, and I'll add another value, so I'll say Tuesday, and I press enter, and there we go. So we basically added another value in an array. But you might be thinking that the days were assigned with the const, so why would it let us to add Tuesday to it? So if I type days and I press enter, and I get that two values inside an array of days, right? And now let's look at with the object as well. So for example, if I create an object, so we go here, and I'll just say const person object is equal to, and we have one first name, and we add, let's just say my name, Awais, right? I'm gonna save it, and let's refresh the browser, and I can access person object, press enter, and I get first name Awais. And if I try to add another key and value inside of a person object, and a person object has been defined by using a const keyword, so let's try that. So we type person dot last name, and we just say is equal to, and we can say Mirza, right? And press enter, and there you go, no errors. So if I access days, I get Monday. If I add person, I get this modified object, first name and a last name. Now what's happening here? The const keyword does not stop us to modify complicated objects, for example, arrays and objects, but it will stop us to assign the days array to a new array. For example, if I go, I'm gonna call the clear here, and then I'll just type days is equal to, and I'll create and add, let's just say Friday, right? I'm gonna press enter, and there we go. It gives you an error. So it says assigning to a constant variable. So you can modify the existing object or an array and add values, remove values, shift values, do a lot of things. But you cannot assign that days array or a person object to a new object literal or a new array. So this will help us to stop assigning the days object or days array or person object to a new literal. So that's the difference between using a const with array and object and with a simple variable which has a one value in there. Alright, so now we're going to talk about the keyword let, which was introduced in ECMAScript 2015, and you can call it ECMAScript 6. Now, before we talk about a let keyword and how it compares to a var keyword, we need to talk about variable scope. So when you declare a variable outside of any function or outside any code block, it is called a global variable because it is available to any other code uh, in the current document. So when you declare a variable within a function, it is called a local variable because it is only available within that function. So before ECMAScript 2015, JavaScript does not have a block statement scope. Rather, a variable declared within a block is local to a function that the block resides within. So I'm going to write a code here. So for example, if you type if, and we can say true, and we add a code block, that block has its own scope. So if I say var x is equal to 10, and outside this code block, if I try to access that by typing console.log, and here we type x, and I'm gonna save the file and refresh the browser, and I get 10. Now what if I change the var keyword to let? I'm going to save the file and refresh the browser, and this time I get an error. It says x is not defined because it does not know what am I talking about, because when you create a variable with the let keyword, it's only available within the code block, so within its own code block scope. So to demonstrate a little bit more and explain the let keyword a bit more, I'm actually going to go to HTML file and show you we have like 10 buttons here, right? We have 10 buttons here, and we're going to go back to the script file, and here I'm going to write some function and a code to demonstrate that. So for example, if I create a constant and I'll say buttons is equal to document dot get element by tag name, and we grab that by typing a button. And then after that, I'll create a for loop, and I'll say var I is equal to 0 and I less than buttons dot length. So we can I plus plus increment I. Now inside this, we have this code block in a for loop, because let keyword is very useful when using with the for loops, and it's the most used for let keyword. So we define the I with the var. So what is mean by this var I is equal to 0? It's similar to if you define var I is equal to 0, and then inside that we just simply say I is equal to 0. It's a similar thing, but I want to just leave that var I is equal to 0 within our for loop, and here inside that I will first of all create a constant again, and we'll just say button is equal to, and I'll say buttons and I, right? So index I. So we grab that one button, and after that I'm gonna add event listener. So we say button dot add event listener. We add an event which would be click event function, and inside that I will just alert that, and then what we're gonna alert, we can say button add a concatenation. Here I add a concatenation and then say pressed, right? Here I'm gonna give a space here so we can differentiate it. Alright, so we create a function, for loop, and I'm going to go and refresh the browser. Now, once I click on any of the button, it alerts button 11 pressed. I'm actually going to make a space here as well. Let's save it, refresh the browser. If I click on button 1, it shows me button 11 is pressed because it is the value of I is always the last value because it is available on a global scope. So it can be accessed outside as well. So that is why we're only getting the value of I, which is always to 11, because it run the loop for 10 times because we have 10 buttons here. So the value of I becomes 11. And when we access that, it always shows 11. Now, what if I change this to let? Once I change this to let, it becomes available only inside our local scope, right? I'm going to save it, and inside this code block, we can access I now. And if I refresh the page and I click on button 1, and now it shows button 1 pressed. And if I go button 4, it says button 4 pressed. And if I go button 7, it says button 7 pressed. So this is how the let keyword, the block level scoping, can help us to achieve these kinds of tasks. Alright, so yeah, that's about it, and I'll see you guys in the next video. Alright, so in summary, constants are your first option when declaring variables. They are used to prevent a reassignment bug and to help you debug your code faster. Constants variable have a block level scoping. So the next option we have is a let keyword is a great substitute for var when you are wanting to reassign a value. For example, when you are incrementing an index in a loop or adding strings together to prevent errors when using for, loop, and adding dynamic functionality to the web pages, the usage of var is not recommended anymore. Since there are a number of scoping issues associated with the var keywords, it's the best to start off by declaring variable with const and then using let and when you need to reassign values. So I hope you enjoyed this video, and I'll see you guys in the next one. Right guys, welcome back, and this is one of the most important section of this course. In this section, we are going to take a look at ECMAS6 specification in details. Now, there's a lot of cool features were introduced in ECMAS6. For example, we now have a let and a const keyword to define a variable. We have a template strings, which we want to talk about in this video. We have a spread operator, map, sets, the for off loop, and also we have some function and objects, new things. For example, defining a function with the arrow syntax. We have symbols, we have iterator, generators, and some asynchronous features as well, which we'll take a look at. So first of all, oh yeah, and the classes. Classes is one of the cool things in ECMAS6. Alright, so let's go to the web storm, and here I have index.html and I have a script.js file. Let's go to script.js file, and here I want to write a string on a console. For example, if I want to say console.log, and I'll say hello world. Right, I'm going to save the file and refresh the browser, and I get this hello world. And now, for example, I want to have a variable. I'll just say var, or we can say let name is equal to, I'll just say John, right? And I'll just want to say hello John. Now, to do that, what I will have to do, for example, if I just remove the word, and then I will have to concatenate the variable. So I'll just say plus name. Right, I'm going to save the file, and I'm going to refresh the browser. And now, as you can see, it says hello John. But it seems like it's a hello John. There's no space between hello and John. So we actually have to go one extra step to have space. Either we have an empty space here, or we can have an empty string with concatenated in this statement. I'm going to save the file and refresh the browser. Now I have a space between it. Now this is one extra step that I had to go to achieve this. All right. Now one more thing we can do here, instead of just using this, we can use a template string. Now let's take a look at the template string syntax. Now here, instead of using single quotes or double quotes, you will use backticks. So backticks characters, and then inside that I will say hello. I'm going to give a space, and then I want to say $, add a code block, and then the name of the variable, which is available within the scope of that. Now let's take a look at a bit more advanced demo. So for example, we want to have a person detail written on our HTML page. Now I'm gonna do it without template string first, and then we come back and do it with the template strings. All right. For example, if I just say, okay, print, right? I'm gonna say person, right? And then I am going to say, okay, I would say name, person, age, and I would just say profession, and I could just say gender, right? And I can say, yeah, that's fine. Right, so here I will basically have to write something. Let's just say I will have to say, okay, I want to grab the name and I want to write that on a document. So I'll just say document.write, and I'll just say, okay, the name would be plus name, right? And then after that, I will have to basically copy and paste 4 times, and I will change the variable names here. So I'll just say age, and then I'll have profession, and also I have a gender, right? So here I will change the name to age, profession, and then we have a gender, right? And then after that I'll just say print, and I'll give a name. Let's just say here Awais, and then I will give age of 29, and then I'll say programmer, and then I'll just say male. Right, I'm gonna save the file and I'm gonna refresh the browser. And now as you can see that we wrote document.write name and all these things, but it actually wrote on the same line, and it actually missing the spaces as well. So name and Awais and age doesn't have a space within, the profession doesn't have a space within that as well. So it's taking a lot more work to finish that. So for example, if I want to go to the next line, I will have to say, okay, document.write, and I'll just say BR, right? I will have to say BR tag here. All right, I'm gonna save the file, refresh the page, and now it's giving us an error. Now the error is because we cannot really have this here. Oops, this is the thing here. I'll save the file, refresh the browser, and now because we wrote a BR tag in our HTML, so that's why we are in the second line. Now you want to have this too many times whenever you want to go to the second line. Now here we can see there's a lot more work to do if we want to have a text written on a separate lines that properly organized. Now let's take a look at the same thing with using a template string. So I'm just going to write the template string right here on the top. So I'll just say document.write, and I'll just choose the backticks now, right? Now here I will say name, and after that I will say, okay, $, and I want to give a name, right? And then after that I will just come down to the next line, and then on the next line I will just start typing something else. For example, I will say age, and then we just say age, and we can pass in age variable, right? And then we can go to the next line and just say, okay, I want to type here profession, and then a $, and then we have a profession. Now it's giving us error because we need to add the template string here. Right. The last thing we need to do is by just adding a gender, and we'll just say, okay, it is gender. Right, I'm going to save the file and just make sure it's fine. Now let's just say I'm going to comment this out. Right, I'm going to comment the code out. And now if I just go refresh the browser, and now you can see that we have a name Awais 829 professional programmer. So it got all the spaces which we wrote here. So every space we have between a name and the variable we define, it's getting its spaces there, right? And also, if I just go and say, okay, that's it. And then inside that, if I just say, okay, BR tag here, I'm gonna save the file and just go refresh the page. And there you go, it's getting the BR as well. So here I'll just type BR and then I go BR, right? And oops, I need to go align this first. And then here we go, BR tag, right? I'm gonna save the file and refresh the page, and there you go. So how cool is that? The template string saved us a lot of time and a lot of code. So we don't have to say document the right or document the right for profession and anything else, and then we will have to have another BR here. Now I'm gonna use console.log so you get a bit of better understanding. So instead of just using a document the right, I wanna type console.log, right? I'm gonna log these details in the console. I'm using this backtick characters, and we just organize this thing. And also I'm going to remove these BRs as well. So we're gonna see what happens if we write this without BR. Oops. Okay, now I'm gonna save the file. I'm gonna refresh the browser. And here you can see that we have name Awais written there, age and stuff like that. Now, I think I haven't reloaded the page yet, so I'm going to refresh that from there. Okay, so let's just go to the next line here. I'm going to save it. Oops. Save the file and let's refresh the page. And there we go. So we're in the next line. As you can see that we didn't have to use a BR or to go to the next line. So template string is basically printing out everything the way we write here. So for example, if we have a space, we have a new line, it is just going to follow that. And also, what are the variable values we're pushing it in with the $sign and in the code block, it is going to get printed as well. So template strings are pretty great to work with. It's so much fun. You can save a lot of time by writing one line with the template string, and you have everything in there, and you can just keep copying that as well. But it is very helpful with the DOM as well. In our final project, we will see how we can use templates strings to actually save a lot of time, and how quickly is it to create a template. For example, details of something, right? An object detail, and you want to write it there. So you don't have to go and basically say, okay, I want to get that first, query selector, and then just create element, BR, then create H1, and then inside that is another text node and all that stuff. So you can simply just go and create your element with the dollar and the variable name, the value you want to put in there, and that's pretty much it is. And it works really nicely. Right, so in the next video, we are going to take a look at spread operator. Welcome back, everybody. So in this video, we are going to take a look at the spread operator in JavaScript, ECMAScript, it's ECMAS6 specification. Right, so here we have three arrays, Awais, John, and Mark. So for example, I will just create another array, and I'll just say people, right? And then I will have a couple of people inside that. For example, if I say, okay, I want to have, well, I can say Tuan, right? Age is going to be 30, and oops, we put that in the string 30, and then engineer in the string as well. And then we just say computing, right? Now here I have one person, or we can say person, right? And then also I'm going to console.log this thing, console.log, I'll just say person. Right? I'm going to save the file, I'm going to refresh the browser, and I can see I have Tuan there, right? I have a Tuan there, so Tuan 30 engineer and computing. Okay, so now, for example, I want to add someone within this person array, and the array I've already created. So for example, if I want to add myself here at the starting point, so just say, okay, I want to have myself always here, right? And at the end, I want to have Mark, okay? And I'm going to save the file and just going to refresh the page. And now here I have something called, like, we have values of Tuan, and then also we have an array within an array. So here, as you can see, that we have an array, and then within that array we have another array saying aways 29 programmer playing games, and at the end we have this array Mark. I'm just gonna make it bigger, and let's just make it a little bit up. Right, so I hope I'm not covering this. So yeah, so here we can see that we have an array within an array. Now, the separate operator will help us to add and spread that array and concatenate that array within the person object. So here, if I use 3 dots, so I'll just say 1, 2, 3 dots, right? And then I'll go to next Mark, and I'll say 1, 2, 3 dot, right? I'm going to save the file and refresh the browser. And now, if I just expand this, now this time, as you can see, that it actually did not add an array within an array. It actually basically opened and spread that array and put that in there. So for example, if I just go and move away from here and then put it here with the comma so we don't have any errors. So here, just remove this as well. And then I'll just remove the Mark spread operator to show you guys again what's happening here. I'm going to refresh the page, and now we can see Tuan, it should be on index 0, and 30 should be on index 1. So here we can see Tuan 30, and then where we put aways, it's starting from there and actually concatenating and opening the array and then putting in there. So this is how the spread operator is used. It's pretty cool because when you add an array and concatenate some variable in an array, you will have to deal with it. So you have to go inside another array to use the data from that. So using a spread operator is pretty cool. It just opens up an array and just put it in there wherever you put the variable name. So here we can see we have an array and then another array for Mark. So yeah. Welcome back, everybody. In this video, we are going to take a look at a new data structure type, a map object, which was introduced in ECMAS6 specification. Now, what is a map object? Well, first of all, it's a key value pair, which holds the data. Now, what is the difference between a regular object and a map object? Now, I'm going to read a description from Mozilla Developer Networks, which will help us to understand what is the difference actually. So objects, regular objects, are similar to maps in both which let you set keys to values, retrieve those values, delete keys, and detect whether something is stored at a key. Because of this, there were no built-in alternative. So objects have been used as maps historically. However, there are important differences between objects and maps. So the first difference is that the key of an object are strings and symbols, where there can be any value for a map, including functions, objects, and any primitive data type. You can get the size of a map with the size property, while the number of properties in the object must be determined manually. A map is an iterable and can thus be directly iterated, whereas iterating over an object requires obtaining its keys in some fashion and iterating over them. An object has a prototype, so there are default keys in the map that could collide with the keys you define, and if you're not careful. So a map may perform better in these scenarios. Additionally, you can add values and remove values by using some methods as well. So we will go to Mozilla Developer Network and we'll take a look at the documentation for a second, and then we'll try to understand a bit more. So I'm here in the Mozilla Developer Network, and here we will go up and we can first of all see we have some properties. So the map.prototype.size, which gives us the size of a map, and we have some methods. So we want to delete, we can use this delete method, We want to have entries. We can use the for each loop. We can get, has, key, sets, values. Let's take a look at the demo as well. So I'm going to move this here, and now we are going to create a map object in a second. So we'll just go to 1 second, guys. All right, so here I want to create a map object, and I'll just constant the log. Now, first of all, to create a map object, it's just simply, let's just say person is equal to a new map, right? We created a map object. So now how do we set the values, or how do we store the values in that person map object? Well, you can do that by person.set and then a key and a value. And now here we can say name, and then a value is like, let's just say my name always. Let's save the file, and let's just get console.log, and we'll just print out a person, right? Let's save the file, refresh the browser, and here we have a map, right? I'm going to just expand this. So here we have the size, which is set to 1 because we have only one value, and then we have entries, which is basically an array. So here we have an entry on 0 index, which has a key as a name and a value as always. Now if I change this name to, for example, a function, which is basically a range, all right, and I will say, okay, in that function, I'll just say console.log, and I'll just say, hey. I'm going to save it. Let's just refresh the browser, and here we can see within that key is a function now. So if you try to add a key as a function in a regular object, it's going to give you an error. So we can see we can have a function as a key of any primitive data, arrays, or symbols as well. So I'm just going to remove this. So that's one difference that we talked about, that we can have functions, arrays, or any primitive data. Right, so here we can have a multiple values. So I'm just going to copy and paste. I'm just going to refresh the browser, and here we can see we have arrays. I'm going to save it actually and refresh the browser now, and here we can see it still has a 1. Well, maybe we're not reloading it. No, we're not reloading it. I'm going to save it again, and I'm going to say, okay, let's refresh again. All right, so did you notice that we added few things here, like 1, 2, 3, 4, 5, 6 name with the keys and values, but it's not even showing them here. So it's getting rid of the duplicates. So here, if I just change the name 1, 2, 3, 4, 5, I'm going to save this, refresh the browser, and now we get map 6. So basically, it actually very smart to actually having duplicate values and just ignore them, right? So here we have a name 1, 2, 3, 4, 5, 6 now. Now, this is how you create a map. Now, how do we grab the values from a map? So we can use in a regular object a dot notation, but how do we use it here? So if I just say, okay, person dot a name, and I'll just want to grab that. I'll save the file and refresh the browser. That will be undefined. As you can see, it doesn't know what we're talking about. What does the name means, right? No, we can't use that. So we need to use a method called get. And then we want to pass in the key. So I'll just say name. Save the file and refresh the browser, and it gives me back the value always. And if I say, okay, give me a name 1. Save the file and refresh the browser, it gives me a waste again, because we have 1, 2, 3, 4, 5. Right, now it should make sense. Let's refresh. Now we have a waste 1. Now we can grab the values by using a get method. We can set the values using a set methods. Now we want to check whether this value is available or not. So here we can check as well. So if I say, okay, console.log, and I'll say person.has, and I can say, okay, does it have this key, name 3? Save the file, refresh the browser, and that gives us true, because name 3 is there as well. So if I just say name 7 as in a key, I'm going to save the file and refresh the browser. Now it gives us false, because name 7 is not available in our person map object. I'm going to delete that. Now we can see we have a has, which can check whether this value or this key is available or not. Now we can see we can grab the keys and we can grab the values as well. So we know how we grab the value, but now we are going to use this, something like this. Okay, so I want to grab person.key, right? And then I'm going to say, okay, let's just say do this, and then I'm going to save the file and just refresh the browser. And now if I call this keys method, it gives us all the keys in an array. It actually removing all the values, not carrying about, but it just grabs us only the keys. So similar to keys, I can use the values method as well. So if we say, get me all the values available in this map object, I'm going to refresh the browser, and now this time we get all the values instead of keys. Now let's take a look at how we can iterate over a map object. So I'm just going to use the person.forEach, and I'm going to pass in another function here, and here I will call, let's just say, person, right? Then we'll just say console.log and just log a person. Save the file and just go refresh, and here we have all the values. Now let's take a look at how we can add key value pairs in our person or map object, right, being in a constructor function. So I'm just going to remove this person.set. Let's remove the loop as well. And now here I am going to go, okay, let's add something. For example, if I want to add an object, arrays, so I'll just say, okay, I want to add array, and then here I have arrays, right? And the next line will have, let's just say another, and here I will pass in, let's just say new date, and the value would be, let's just say today. All right, and then we can save this, and let's just refresh the browser. But before that, we need to console.log person object, so we can see the results for that. Save the file, refresh the browser, and here we have an array which has like values. So we have keys, arrays, 29 programmer playing games, and then also we have a date object, and the value for that is today, right? So you can just write your you can add your data to a map object, right, being in a constructor function as well. So it's basically an arrays of arrays. So you have one array, and then inside that you add multiple arrays, right? So that was a data structure introduced in ECMAS6, which is a map object. And in the next video, we're going to take a look at sets. Welcome back. Now in this video, we are going to take a look at set object in JavaScript. Now the definition or the simple way I could explain to you set is the set objects are a collection of values. You can iterate through the element of a set in insertion order. So a value in a set may only occur once, and it is unique, so you can have a duplicates in the sets. So we're going to take a look at the demo as well. Then I'll take you to the documentation on Mozilla Developer Network. So we'll look at all the methods and properties available for sets. So for example, here I will go, and I'm just going to make it bigger so it's better to see. Let's just say we say number set is equal to, and I'll just get an array, and we can say 1, 2, 3, 4, 4, 5, 6, 6, or we can say 1 again, 2 again, and 7, right? So I've created an array of numbers, right? So I'm going to say, okay, let's just create a set number, or we can say num set is equal to new set, and we can pass in a number set, right? An array. And then we can just go to console.log, and we just say num set, just log that. So right now we have some duplicates in our array. So we have 1, 2, 3, 4, 4 is a duplicate, and then 5, 6, and 1, 2 again is a duplicate. So let's just say save the file. Let's refresh the browser, and here we get a set object. Now here we have some entries. So it says 1, 2, 3, 4, 5, 6, 7. What about these 1 and 2? What about this for here? So as you can see, the set will ignore the duplicate value within the set object. Now let's take a look at some of the methods available in a set object. So first of all, we're going to take a look at add method. So add method will let you add values inside of a set object. So here I'm actually going to remove this array and I'm going to add values right being in the set object. So here I'm going to say, okay, num set.add, right? I'm going to add a value here. So here I'll just say, okay, the name of the person, I'll say John, right? Num set, we need to change the variable name, but it's fine. Okay, so here we say Paul. I'm going to save the file, refresh the browser, and here we can see we have a John and Paul. So what if I add one more time? So I'll say John add second time, refresh the browser, and still it ignored that because it cannot have a duplicate values. As you can see, the John is not. Now if I have some add methods, so I can have different methods as well for deleting and checking whether this value exists in the set or not. So here if I say, okay, console.log, and I'll say, okay, numset.has, and I'll say, okay, does it have a John in it? I'm going to save the file, refresh the browser, and here it says yes, true. So it has a John. So we can call the has method, like with the map object, we can call has method on a set object and check whether this value exists in a set or not. So here if I check, okay, ABC, I'm going to save the file and then refresh the browser, it gives me false because ABC doesn't exist in a set object. So we can see that we can add, we can check. How do we remove it now? So if I just say, okay, let's just remove this console.log, remove this as well. First of all, let's just right click and we can go refactor and rename, say person. All right, so now I'm going to change the name here. I'll just type my name, and now I'll just go down, and here we just say person console.log, and we just say person. Right. Now I'm going to remove aways from this person set object. So we can do that by calling a delete method and giving it the name, a value. So I'm going to save the file and refresh the browser. And now I can see the person object has John, Aways, and Paul. But what if I just go and move this down, save the file and just refresh the browser, and now I have only John and Paul. So you can see that we have successfully removed aways from a person object. Now we can use a clear to remove all the elements. So for example, if I say, okay, clear, and then we can just call this method and save the file and refresh the browser. And right now we have a set object, but it doesn't have anything because we have cleared it. So the clear method is there as well. We have the for each, which we just seen in the map. You can use the for each as well. So for example, if I go and say, okay, I want to have a person, and then for each, I want to call another function. Let's say e as an element of value. So we just say console.log, we can pass in e. All right, and save the file. All right, so we get John, Aways, and Paul. So we can iterate over sets as well by using for each method. Now we can check has with the, we can check that with the has, we can check all the values for that. So we can have a set property as well, sorry, size property. So here if I say, okay, well, console.log and person.size, I'm going to save the file, refresh the browser. As you can see, we have 3 entries in a set object. So that is a cool and data structure which does not allow duplicates. Welcome back everybody. In this video we are going to take a look at the for of loop statement, which basically creates a loop iterating over iteratable objects. For example, We have strings, arrays, node list, typed array, maps, and set. We can iterate over these objects using for of. So for example, if I go to PHP Storm here, I'll just say, okay, let person, or let's just say, we can say programming, okay, is equal to, say, JavaScript, right? Now, what if I want to iterate over this JavaScript value? So we can say for, and then here we say, okay, let A or let X of programming, and then we can just say console.log x. Now save the file. Let's just refresh the browser, and here it goes inside that, and then read, okay, the first character J, it prints out. It goes to the next character. So it's iterating over a string right now. Now we can use the for of loop for iterating on arrays as well. So for example, it's time to create an array. So what is your favorite programming language so far? So I can say here, mine is JavaScript, C++, or we have a Java, or Ruby. So I'm just gonna make it smaller size so we can look at it, and then we can say Python. All right, I'm gonna save the file. And now if I refresh the browser, it'll go and look for the first letter or word on index 0, prints it out, C++, Java, and Python is there as well. So let X is a variable which holds the current iteratable value. So it's an array, 1, 2, 3, 4, 5, 6 in the array, okay? So the first is 1 value. So we can say, okay, let X is a variable, a placeholder, and store the first value of iterable object into the X. And then we just go inside the function and do whatever we want to do with the X. And then we go back and then go grab the second one and store that into the next. So this is like how X work, because when I was using it, I had a bit of confusion about it, but I hope you understand this. So basically let is just a variable name, which is going to store the value temporarily for a specific index of an object we are iterating on. So here we can see we can iterate over arrays. Now let's take a look at how we can iterate over an object. So for example, if I go and create a map, so let's just say we create a new map object, and then after that we are going to set some values for. So we can say, okay, we can say programming.set, and first of all let's just give a key, let's just say HTML, and then we just say, well, I'm just gonna say, what can I say about HTML? Hypertext markup language, right? And then we go add something else. We can say programming.set, we can say scripting, and we can say here JavaScript is so cool, right? And then we say programming.set, we can say CSS, and then we can say style style.html. Right, I'm gonna save the file. Now let's go refresh the page. Now as you can see, it's actually going inside the programming now, and it's grabbing this first value, and then we can see, okay, we have the 0 index, it's a key, and then 1 is a value. All right, so here another thing about iterating over map object. So here we can say there's a programming there. If I call a function.keys, I'm gonna save the file, I'm gonna refresh the browser, and it's giving me some kind of an error. So here we can see we have a programming, we have a keys, right, instead of key. Let's save the file, refresh the browser, and there we go. So right now we grab this programming object, which is a map object, and we just say, okay, I'm gonna grab just the keys from that, and then just put that first value into the next, and then go inside a function and work with it. So it's similar to getting a key. I can pass in dot values as well. I'm going to save the file and refresh the browser, and now we're getting hypertext markup language. JavaScript is so cool, and style HTML. So how cool is that? You can grab keys or values from a map object and using for off loop. It's really cool. The last method I want to show you in for off loop is the entries method. So here, if I call entries, let's save the file. Let's refresh the browser, and here we can see it returned us the object. So yeah, that is iterating over object strings and arrays using for off loop, and you will be using for off loop a lot more. So this is so cool. Welcome back, and this is another coding challenge for you guys, and I hope you guys are excited about it. Right, so the challenge is by using for off loop and iterating over languages array, but instead of just getting JavaScript, we want to grab the values of JavaScript key. So inside that, I want to print out JavaScript. So if I go inside, let's just say for, let's let x of languages, and I'll just say, okay, console.log, and I'm going to say console.log x. I'm going to save and refresh the page. Now we are basically grabbing these values of JavaScript, C++, Python. So what I want to do is I want to grab the character of actual values on index 1. So this is the challenge for you guys, and yeah, if you want to give it a try, I would highly recommend do that and pause the video. So the last chance for you guys to pause the video. Alright, so I hope pretty much all of you was able to get this done. So what we can do, so first of all, we can see the problem. The problem is that this loop will go inside our array and grab the first value, which is on 0 index, and then on 1 index and 2 index, and then onwards, right? So we have x here. I am actually going to use another loop. Now we're gonna have a loop within a loop. So we say, okay, go grab the first value, and it comes back with a JavaScript. And I say, okay, I've got a JavaScript now, and then I wanna loop through a JavaScript string. So we can do that by using for let a or let y of x. How cool is that? Now once we go and grab the value of x, and then we go inside and say, okay, x is here, which is JavaScript, then I want to loop through the x as well. So here I'll just say console.log, I'll just console y. I'm going to save and refresh the browser, and there we go. So here we can see JavaScript, and we go C++, and then we go down, it says a Python. So loop within a loop. We have a lot more coding challenges related to loops and iterating over objects, which will give us a nice idea how actually things work and how to solve these problems. Because in your programming career, this is the main problem you're gonna have. This is the problem, and you're gonna solve these. So we have a 50 objects which inherits from other objects, and there's objects inside on objects. This is a complete mess. Now, getting the values from those objects and manipulating them, it's a bit of tricky business. So we want to have a lot more coding challenges. So yeah, that's about it for this video, and I'll see you guys in the next video. Welcome back. In this video, we are going to take a look at default parameters in function. So prior to ECMAS6, we really didn't have this feature to define a default values for a parameter we pass into a function. So for example, let me give you a demo here. So we just say function add, I pass in x parameter and y, and I will just say, okay, return console, or maybe just console.log. We don't really need to return console.log and say x plus y, right? Save the file and this is called add function. Here I'm going to save and refresh the browser, and now basically I'm actually not passing in any value, so it's giving me NaN, so not available. So what we want to do here, we want to have a values as a default, so if the user doesn't pass in any values while calling the function, it should have a default values in there. So we can do that by just adding equal to sign, and then we just give 5 as a default value is equal to, let's just say 5 as well for the y. I'm gonna save the file and just go refresh the browser, and now we get 10. So we have the default values. But what if I just pass in, let's just say 2, 2, 3. I'm gonna save the file and refresh the browser, and now we get 5. So the only time this default value is going to assign to x and y when the user or the developer doesn't pass in the value. So if I say here 10 plus 3 should be 13, and now we get 13. So this is how you can define a default parameters to the function parameter. So we can take a look at another example. I can say here, all right, let's just say name and hobby. All right, so here we can say, okay, the name by default should be admin, and this should be, oops, I need to push it in as a string. Hobby is programming. All right, so here we have admin, or whatever the name you want to type in here. Right, and here I can just go, okay, we can use the template strings. So here we can say the name is, and here we can say $, and then grab the name, right? And then I can say, let's go to the next line, and here I can say, when I go into the next line, just want to organize some stuff. Right, so here I want to say the hobby is $, and we just say hobby. Right, now if I call this add function, we should have changed the name of that, but I'll just leave it as it is. So here if I say okay, I'll just give it a ways, and I don't give a second parameter. I'm gonna save and refresh the browser, and now it says the name is always and the hobby is programming. Well, I did not pass in any second parameter for a hobby. The reason why I took it, because we have a second parameter and we have a default value for that. So if I say okay, I'm not gonna pass it anything, it's make it empty, but it's still a value, right? So if I say okay, ABC, now guess what's gonna happen? I'm gonna refresh the browser. Now it says the name is empty because we're still giving some kind of value here. All right, and then we pass in the ABC as a second parameter, right? So it's gonna override the value, a default value of hobby in there. Right, so one more thing in this video we can talk about is, I'm just gonna remove this. So we have something called enhancing object literals. For example, when you create an object, so let's say person is equal to this, and I would just say name, and we'll call it function, and it would just return, let's just say always, right? And I can say okay, the second would be age, and then say function, and then we just say, well, return 29. All right, I'm gonna save the file. Okay, and I'm going to just, let's say console.log, and we can just say person.name, right? So here, if I just refresh the browser, it's gonna give me a waste because the return value is always, right? Now in ECMAS6, we don't really have to type it in a function anymore. So when you're assigning the key to a function, then you just simply say, okay, I am just going to use this name, right? So you don't really have to define a name, and then we just have, okay, well, this is it. So this is the function, and I'm gonna save the file now. I'll just refresh the browser. As you can see, it works the same. So if I call the age, I'm gonna save the file and just refresh the browser, it gives me back 29. So basically ECMAS6 enhanced this object literals. So here, if you're defining a function, then you just simply define a function, and that's about it. Alright, so yeah, that's about this video. In the next video, we're gonna take a look at arrow function syntax. Welcome back, everybody. In this video, we are going to take a look at arrow functions. Now, arrow functions were introduced in ECMAS 6. So what is the definition? Let me explain to you quickly. So an arrow function expression has a shorter syntax than a function expression, and it does not have its own this, argument, super, or a new target. Now, these function expressions are best suited for non-method functions, and they cannot be used as constructors. So let's take a look at how we define a function first, and then we will convert that into arrow function syntax. Alright, so let's go to PHP and start looking at arrow function syntax. But first, we can have a look how we define a function expression. So it's very simple. We've been using it throughout the course. So if I say var person is equal to function, and I'll just say, okay, person, and I'll just say console.log, I'll say log the person. Right, so this is the function I define, just a normal function expression. Now I can say, okay, I want to call this person, and I'll just say John. Alright, I'm going to save the file. I'll just refresh the browser. I can see the John is on the console. Now this line on this line can be shortened. I mean to say the function can be written with arrow function syntax, and it would be a lot less code. So how do we change this to arrow function syntax? So first of all, I'm actually going to remove this keyword function, and I'm going to go and add is equal to sign and a greater than sign. So this is an arrow function syntax. So now one more thing here, if I just, first of all, let's look at it. So if I save the file and refresh the browser, I can see it still works the same. Now how we can make this more sure. So if I go and remove this block of code, and I'll just bring up the console.log, and here I'm going to save the file and refresh the browser, I can see it still works. So if only one parameter is defined, we don't really have to have a code block, alright? And also, if there's only one parameter, I don't even need these parentheses around our parameter. I'm going to save the file and just refresh the browser, and there you go, the John still prints out. So what are the few syntaxes of arrow function? So here we can see with one parameter, this is how we define a function. Now let's create a function without any parameter, which is very simple as well. So if I say var a is equal to, I'll just open the parentheses, is equal to sign, and then greater than, and that's pretty much it. Alright, so I'm going to say, okay, inside that, or I can just leave that thing there, and he'll say console.log, we'll just say arrow function works. I'll save the file, and we just need to call that function. So we just say a, that's pretty much it, and then we go refresh the browser, and it says arrow function works. So this is how you can define a function without any parameter. So this video is a little bit of introduction about arrow function syntax. So in the next video, we are going to take a look at the this keyword in arrow function syntax. Welcome back. In this video, we are going to take a look at arrow functions and the this scope. So let's go to PHP and here we are going to create an object. So I'll just say var, I'll just say person is equal to, we create an object. First of all, we give it a name. So let's just say a name, and I'll just say John, right? And after that, I'll have another key, let's say hobbies, and we will pass in an array for that. So here we just say programming, JavaScript, and we can say fishing and playing games. Oops, I need to put that in a string, and we can just make it a little bit smaller so we could just look at this in the screen. So we just say video games. Right, so now we have an object. Now the third key is going to be, let's just say, we call it print actions, right? And I'm gonna pass in a function for that. And here for that, we are basically going to grab the hobbies, or we can say print hobbies here. So just say hobbies, and here we're gonna print all the hobbies available in this person object. We can do that by accessing hobbies by using this keyword dot, and we can say hobbies. Grab me this dot hobbies. So it's gonna reference to the object itself and its properties. So this keyword is going to reference to object itself, and then we say dot hobbies, the key of which is available in an object. So now here we can say this dot hobbies dot for each loop, and it's gonna take a callback function. We just say okay, and I'm just gonna give a parameter hobby. Now grab the hobby, and I'll say create a new variable. I'll just say str is equal to. Now I want to grab name key from a person object. Now right now we can see we are in a function scope. We're not in object scope anymore. So if I type here this dot name, and I would just say okay plus, and I can just say likes, and then we can say hobby, right? And here we want to have a concatenation operator, not is equal to operator. Now we can just say console.log, and we can say console.log string. I'm going to save the file, and let's go and call this. So we just say person.print hobbies, right? And let's save the file and refresh the browser. And here we get likes programming, likes JavaScript, likes phishing. But what about this dot name? Well, we are actually trying to reference that to this dot name. Well, it did not actually print out the name of the person, which is John. Now, how do we fix that? So here we have a this, which is referencing to an object itself. So this is why when we get inside this function, we say this and dot name, it is not able to access the property on the person object. Now, how do we fix that? How can we get this working? So there are a couple ways that you can do that. So I'm going to go inside a function. I will just say var is equal to, this is equal to this, all right? Now we'll just say, okay, I'm gonna create a variable this, which is set to this. Now instead of this, if I add an underscore here, and I'm gonna save the file and refresh the browser. And now as you can see, we are able to access the name property from an object. All right, so another way to get this working, I'm actually going to remove this line, var this dot this. So this underscore this is equal to this. Okay. Now here, I'm going to chain on with the bind method. So I'll say bind, and I will just say here this. Right. I'm going to remove underscore from here, and now if I save the file and refresh the browser, and we can see that John is getting printed. So we are able to access this name key within our for each function. Now, arrow function syntax solves this issue. Let's take a look at how we can modify this function and try to make the this.name working within our for each scope. So I'm going to remove bind this. I'm going to save the file, and here we are going to go and basically remove this function, and I'm going to remove this as well. So now in ECMAScript 6, you know that you don't have to define the key for a function within an object. So here we say print hobbies, which is a function, and here we can say this dot hobbies for each function. So here the callback function is going to be converted to an arrow function syntax. So to do that, I'm going to remove the function keyword, and also I'm going to remove the hobbies because it's only one parameter. So if you have a multiple parameter, you need to have a parenthesis. Well, let's just keep the parenthesis for now. So we'll just remove it so it's not confusing for you guys. Now here I'm going to use is equal to and then greater than sign. And also I can't remove this code block because we have a multiple line of code within our function. So let's save the file and let's refresh the browser and see what we get. And there we go. So here you can see John is there for like programming, like JavaScript, likes fishing. So now we are able to access this key by using the arrow function syntax, and that function solves this issue. So that was a video about arrow functions and the disk scope. In the next video, we are going to talk about a destructuring assignment. Welcome back everybody. In this video we are going to take a look at a destructuring assignment available in ES6. Right, so for that we're going to go to PHP Storm, and here I'm going to create a variable and I'm going to call it let's just say programming. Right, I'm going to say, okay, what are my favorite programming languages? So first of all, JavaScript is my favorite. And then comes Java, and then we have C++, and then we have Ruby, and then we have Python, right. So now if I want to use a destructuring assignment, so for example, first of all, before we can use the destructuring assignment, we're going to understand how we can retrieve the values from an array. So we already know that. We've already talked about how to retrieve. But just quickly take a look at programming. If I say, okay, 0, and that would be console.log, and then we can just log it on the console. Let's refresh the browser. We can see we can grab JavaScript. Now I'm going to use the destructuring assignment to actually access the values. Instead of just typing the keys index of that value, I'm just going to destructure this array. So instead of just typing the name here for the variable, I'm actually going to use square brackets. And inside the square brackets, I will just say, well, we can just say first, and I'm going to type a comma here and then say last. Right, I'm going to save the file, and if down here, if I try to const.log first, and I'm going to refresh the browser, and you can see I'm able to grab the JavaScript from an array. How this thing is working? Are you confused? Don't worry, we're going to make sure that you understand what I'm talking about here. Now here, when I use this destructuring assignment, where I have a square brackets and I pass in a variable name and a second variable name. So what if I console.log last here? I'm going to save the file, refresh the browser, and now it gets me Java. Now how is this working? Now basically what is going on here is that the first variable you define in a destructuring assignment, that will be linked to the first index of an array, which is 0, and then second variable you define here, which will have the value of index 1, and so on. So for example, if I want to create first and the last variable, and I want to assign the first variable to JavaScript and the last variable to Python, how do I do that? Well, we can do that by simply defining the commas. So for example, this is a 0 index. I'm just going to bring it down. Actually, here we have more space now. So this first is equal to JavaScript because it's the first index. Now here I will go and add another comma here. Now within these commas, there is no value at the moment, right? So what is going to happen is that the first is going to equal to JavaScript, and then here in the commas, it is going to grab Java and put it in there, but there is no variable defined there, so that means we just can't use it. So we just define a comma to just skip the value in an array. So for example, so we have a 0 index, and Java is on index 1, and then we have index 2 for C++, and index 3 for Ruby, and then Python for I don't know, 0, 1, 2, 3, 4, yeah, 4. For example, if I add another comma here and then another comma here. So what's happening? So first, which will be equal to the first index of an array, and then we have a second, third value, and the fourth value. And the last value is going to be null or undefined because there is no fifth value available in an array. So I'm actually going to remove one comma here. And now I'm going to go and say we can console.log first and then the last. Now before, when we console.log last, it had Java because it was directly defined after the first variable. So I'm going to save the file. Let's just refresh the browser, and there you go. So we get JavaScript, and then we get last as a Ruby. So what's happening here? So for example, we have 0, 1, 2, 3. So 0, 1, 2, 3. That's actually right. We need to add another comma to get the last value. Save the file, and let's just refresh it. Now we get Python. Now if you want to skip the JavaScript, what we can do here, I'm going to add a comma here, and now if I just save the file and refresh the browser, and this time I get Java. And because we have another value here, and the last value is on index 5, 4, so the last will become here 5, I guess, which is undefined, which is not available here. So here, if I remove one comma here, oops, I want to remove a comma here, I'm going to save the file and refresh the browser, and get me back to the last value of Python. So this is how you destructure an array, and that can be applied to objects as well. So this is a cool thing about it. This is really cool. We're gonna make use of it in our main proper project, right? So I'll see you guys in the next video. Welcome back, everybody. In this video, we are going to take a look at a generator function. So generators are a new type of function that allow us to pause function in the middle of execution and to be resumed later. So, you are looking at a generator when you see an asterisk immediately after following the function keyword. Or sometimes you will see people use the asterisk right before the function name. So we hit the pause within our function by using the new yield keyword. So wherever you see yield keyword, that means we pause the function right there. And this can be used multiple times within the same function. So let's take a look at the syntax to define a function. So we just say function, and then we use asterisk and then the name of the function. I'll just call it my function, and we're going to pass in a parameter here, I, and here I will just say yield I, right? And then we have yield I plus 5. I'm going to save the file, and now we are going to call this function. But before, let's take a look at what it's going to do. So calling a generator function does not execute its body immediately. So an iterator object for a function is returned instead. When the iterator next method is called, the generator function's body is executed until the first yield expression, which specify the value to be returned from the iterator or with the yield. So let's take a look at that. Now, one more thing, calling the next method with an argument will resume the generator function execution and replacing the yield expression where execution was paused with the argument from the next. So a return statement in a generator, when executed, will make the generator done. And if the value is returned, it will be paused back to the value. And a generator has a returned will not yield any more values. So you got an idea what I just spoke here. Now, if you want to have a look at the reference and learn about more in details about generators, then I would highly recommend go to the Mozilla Developer Network and take a look at generators. But now let's take a look at a generator at the beginner level. So here I have the function. I'm just going to create a variable. I'm going to call it gen is equal to my function. And then I'm going to pass in, let's just say 10 as a parameter, right? So what's happening here? Now I am going to console.log gen. So let's just say console.log and here we just pass in gen. And now I am going to just console.log this and see what happens. We save the file and refresh the browser, and it returns the function. It says suspended, and the prototype is a generator. So here we have a generator status, we have a generator function there, and now how do we get inside to the yield, right? So we get the value from that. Here we have just talked about we need to call a next method on it. I'm going to call the next method, and let's refresh the browser, and now it creates a generator object and returns. So it says done is equal to false, which means that the function hasn't been executed completely because there is another yield available there. So what if I just say, okay, console.log I, and I will just concatenate something like string here, which saying just logged this. I'm going to save the file and just refresh the browser, and now we can see the value there, right? Because we're calling this gen.next. Now I'm going to basically copy and paste this, right? I'm going to save the file and refresh the browser. And now as you can see that when our function, so if our compiler goes here, it sees the yield and say, oh, I'm going to pause the function. I'm not going to execute the rest of the code, right? So now when it goes down, it says, okay, we call gen.next once. That means I'm going to execute till the first yield. And then it goes and sees, okay, gen.next is there again. So that means it's going to call the next yield. It's going to call all the code until the next yield is there. So this is how you can pause the function. We will use generator function in our final project. So yeah, that's about the generator function, guys. Alright guys, welcome back. Now in this video we are going to start looking into classes, which are pretty exciting topic, which were introduced in 2015 in ES6. So what are classes? Now primarily classes are syntactical sugar over JavaScript existing prototype based inheritance. So the class syntax does not introduce a new object oriented inheritance in inheritance model to JavaScript. So classes are in fact special functions. So just like you can define function expressions and function declarations, the class syntax has two components, a class expression and a class declaration. So the class declaration, one way to define a class is using a class declaration. So you declare a class with class keyword, with the name of the class, and now class expression. So class expression is another way to define a class. So class expression can be named or unnamed. Well, the named given to a named class expression is a local to a class body, and it can be retrieved through the class. So let's go and take a look at how we can define a class. So we're going to go back to PHP Storm, and let's have a look at the class keyword. So now let's say, first of all, let's go back and see how we create objects and we create a constructor functions, right? So we go as like your constructor function, we just say rectangle, and I say, well, width and height, right? So here I will just say this dot width is equal to width, and then this dot height is equal to height, right? And then I can just say, okay, let rect is equal to new rectangle, right? And I'm going to give like 20 by 20, and then that makes a rectangle. So let's go refresh the page, and here I've done the wrong spelling, rectangle. Okay, we've done the wrong spelling here, so we just gotta go fix it. Right, so here if I just say, okay, console.log, and I'll say rect, and then I'll just go and refresh the page, and here we can see we have a syntax error. Alright, so we're supposed to have this semicolon, not a colon. Let's refresh, and here we have a rectangle object, right? Now, this is a constructor function to create an object, but now we have a keyword called class, which help us to create classes, which are basically an object at the back. But let's take a look how we can create that. I'm going to remove this code, and I'm going to define a keyword class. So let's simply type a class. And after that, you need to type the name of the class. So we'll just say a person, right? And I'm going to have code block. So let's go inside the class. So we don't add parentheses here. We add a curly braces. So that's called code block as well. So now here we need to have a special function to create or to retrieve the parameters of the class. So here what I'm going to do, type constructor. So what is a constructor? Now, the constructor method or function is a special method for creating and initializing object created with a class. There can be only one special method with the name constructor in a class. If you have a multiple constructor in a class, you will have a syntax error thrown. For example, let's take a look at the demo. So here I have a constructor. I'll just say, all right, I'm going to take a name of the person, an age, and profession. Right, and then I'm going to just go down and I will just say this dot name is equal to name, this dot age is equal to age, and this dot profession is equal to profession. Right, now here if I define a constructor again, and I'll just say hey, and I'll come this dot hey is equal to hey. I'm going to save the file, and let's just go and refresh the browser, and here we have a class may only have one constructor function, right? So my statement is right. So I just got to remove this constructor. So you can only have one constructor in the class. Now we have this class. It's time for us to create an object from this class. So I'll just say let John, right, is equal to new a person, and I'm going to just say okay, name is John, age is, let's just say 30, and profession is, well, we can say programmer, right? Let's save it, and I'm going to console log John, save the file again. Let's refresh the browser. I'm just going to make the browser a bit bigger. Let's just go make it a bit bigger here. It's gonna make alright, now here we can see we have a person object with the age, name, and a profession. Well, we have successfully created a class, and we also know how we can create a class, what is a constructor function, what class do for you. So yeah, the next topic we're gonna talk about is class inheritance, right? So here I will create another class. So let's just remove John for a second, right? Now here the person class tells us the name, age, and profession, right? Here I'm going to do a bit of modification. I'm going to remove this, and I'm going to remove this profession here as well. So just want to have a name, right? And here, the next line, we are going to define another class. All right, I'm going to create another class of student. Right now, let's take a look at what I'm explaining here. Like, let's take an example. Now, let's say we have a class of person, and we create a class of student. Now, student is a person as well, isn't it? So, student is a person, right? So the properties of the person should go inside a student as well, but student has more properties than just a person. For example, student must have a name, student must have an age, and just for the student, it should have a class or a grade or roll number in a class, or some kind of a special subject he's studying in this school. So this person might not have those properties, but student will. So what we can do is we basically can inherit from a parent class, and we make the parent class as a person class. Now we are going to use a keyword called extend, to actually inherit or make a parent class of a student class. So we'll type extends, and I'm going to type the name of the class which it inherits from, which is a person in this case. So here I'll just say, okay, I am going to create a student class, and it's going to extend to a person. So now the next thing we do is we create a constructor for this class, and then inside we pass in parameters, or we can just get inside the constructor, and then we are going to use a keyword called super. So type super here, and then we are going to type name and age. Now the keyword super is referring to the parent class constructor. So the parent class constructor requires name and age. So in the super, we need to define that what we are going to give a values for name and age, because we're inheriting from a person, which is a parent class. Make sense? Right, so here I'll say, okay, I'm going to create a string, John, and age 30. Let's go down, and then after that, I'm going to add some properties for a student, just for the student as well, alright? So just say school. What school does the student go, right? What grade the student study? So here we just come down, I would just say this dot school is equal to school. This dot, and we can say this dot grade is equal to grade. Right, now we are going to get outside of the class, and let's try using it. I'm going to create a new instance of a student. So we just say new, and I'm going to say, okay, I'm going to let I put my name always, and I'll just say, okay, I'm going to say new student, right? And here I want to type school and grade value. So here I'll just say, okay, I go to IT school, and the grade I study is in 12. Well, I don't, but I just say, I'm going to save the file and just let console.log, and I'll just say it. Just log the aways. I'll save the file. Let's refresh the browser. And here I have a student class. So the student class has a name John, has a grade 12 and a 30, and IT as well. Now here I am using these values, but I can simply say here, alright, I'm going to say in a constructor, I'll just say name, and I'll just say age, right? And then here I will just say it's a name and age. Okay, now basically we are passing the name and age value in the student constructor, and you might be thinking, why would you do that? Because when your applications grow bigger and bigger, then you need to manage your code. You need to understand where this thing's coming from, what are the object, what is the parent object. So this basically help us to manage the project. So right now, if someone sees the student, it's going to see that, okay, super, and this is going to be this class, but person can extend anywhere else in the project. It could be a student and a teacher and a principal or a headmaster or some kind of a PT teacher. So the person goes with everywhere, but we still have a person. So now if I go save the file, I'm going to get a student, which is undefined grade and undefined student, because the first two values are going to be for the constructor in a superclass. So here we have defined IT as a name, and we have defined age 12 as a string. So here, if I just remove this remove it, and here I'll just say let, and I'll just say, okay, I'm going to create John now. It's equal to new student, and first of all, what I need to type here. So here the PHP or web strong giving me suggestions here. If you take a look at it closely, I'm just gonna zoom into this. So it says name, age, school, grade. So the first parameter is going to be name and age, and then school and grade. So here I can say, okay, well, we can say here, I'll say John is the name, age is 30, and then school, I can say IT. And then we can say grade, we can say JavaScript here. So let's say JavaScript, right? And then after that, let's take a look at what do we have in John. So it's the console.log, we say John, and let's refresh the page, but must remove this colon to semicolon. Let's refresh the page, and now we can see we have age, we have a grade, we have a name, we have a school, right? The next topic we're going to talk about is setters and getters. Well, getters or setters or getter are pretty much the same thing. Okay, so getters and setters are available in other programming languages as well, like in Java, C++, or Python. So in JavaScript we do have a getters and setter, but it's a little bit different, right? So here I'm gonna go on the person, or maybe we can do that on the student class. So here outside the constructor, I'll just create a function. I'll just say get name, add a function, and here we can just say return me this dot name, right? Also, I want to set the name. I want to go and change the name of this student later on. So I can just say set name, and I can give a parameter of name, and I can just say, alright, this dot name is equal to name. Alright, and then on the next line we can say, okay, get age, and I can say, alright, return this dot age. And also we're gonna have a set age, and then we can just say this dot age is equal to age, which I haven't passed in yet, but there you go. So we pass in a parameter of age, right? So now the next property we have school. So say get school, add a function there. I would just say return this dot school. And also we are going to add set school, we can say as school, and I'm going to say return, not return actually, I said this dot school is equal to school, right? So basically what we're doing here, we're just creating getters and setters for that. So we have one function to get the school name, we have one function to set the school name. Right, the last thing we have a grade. Let's do that as well. So here I'd say get grade, grade, no grade. Okay, so grade, that's the right spelling. Right, so after that we just say, okay, I'm gonna go to the next line. I'm just gonna write it here, it's easier. So set this dot grade. Alright, that's done. So say set grade, so parameter grade, and I'll just say return. Is a return? No, it's not. So we just say this dot grade is equal to grade. Right, so finally we have created our setters and getters for all four properties. I'm going to refresh the page. Right now I'm going to say, okay, give me a John. What's the John in there? Enter. Now John has this object. It has an age and a grade, JavaScript name, and John, right? Now what if I call this function John dot get name? Well, it gives me back the John. Okay, John is the name. Well, we're gonna set the different name for a John. So here I can say, okay, John dot set name, and I'm going to say aways. Press enter. It gives me undefined. Well, don't worry. Now let's go and have a look at John dot get name and enter, and this is what we get. We get aways. Now there's no John anymore. Let's take a look at the John object completely. So I'm going to press enter, and here we have a John. I think it's hidden behind me right now, so So I'm just going to clear the thing out and we just say John. There you go. So John property aways is there. No more John is there anymore because we've changed it. So same as with changing a name, we can use the setter for a grade as well. So we'll just say, okay, John set grade, and we can just say, okay, he wants to learn Python, not JavaScript. So let's press enter, and I'll just say, now I'm going to clear the console and just say John, and here just press enter, and now let's take a look at what is a grade for a John. Alright, cool. So we have successfully changed the value of the grade for a John object. So this is how we can define setters and getters. So later in the replication, whenever we need to change the value or grab the value or do some functionality, for example, if you want to get the grade of the student, so there must be a function here. Let's just say we can create, so get calculate grade and then return the result. All right, return result. Now here we don't have a result at the moment, but you're gonna have to create that functionality and the result from this function. So that means once we have the grade, oops, I'm going to fix this up. Right, so now I think I'll press the Control L to identify, so ident the code. Let's make it smaller. All right, now this function will have all the things. For example, total, so let total marks is equal to 100, and then say, well, student marks is, we can say, okay, this dot, and we can say John, or we can say get grade, right? And that's what we want to have, something like, let's just say, we can store a variable here. Oops, I'm going all the way up there. So it's a let student marks is equal to this dot get grade. This is going to grab us a grade. Now we have the total marks and the marks the student got, and then after that we do some functionality. We just say, okay, we can have let result there as well. So here we just say, okay, well, I'm going to say result is equal to total marks minus student marks. All right, now the student marks will have something like, I don't know, 30. So here we have result, yeah, that's fine. Let's save it, and then I'm gonna refresh the page, and here we just see John, enter. Now student marks are 30, our grade is 30, right? So we need to have age actually here, so I'm just say age. Let's save it. Let's refresh the page. Oops, we need to have a get age. Save it. Let's, because the age has the numeric value 30 here, so we have some problem with the naming, but let's do it. So we have a John object, age 30. So here I'm going to say John dot, and what is the function name we defined? Get calc. So get calc grade. Oops, and enter, and it's say, okay, resolve is not defined. Well, that's right, because RE result is not fine. Now it should be fine. See the mistakes I make on purpose, because later on I can tell you this is going to happen in the programming career. You always make mistakes, but the best part about it, if you know how to fix them, that is the good thing about it. Let's go refresh the browser, and I'm just gonna quickly say john.get calc, enter, and there you go, we get 70. We did some kind of functionality, right? So we know that we have a function which will basically give a minus value from 100, whatever the grade is, so that's 70, right? It's a weird function, but it does work. So what if I go and say john.set age to, we can say 50, right? And then I'm going to say, okay, john.get calc grade, I'm going to get 50 because 50 was there for the John, not 30 anymore. So here you can see we create one object. Now we have some functions in that which will manipulate the data and give us the result according to the stuff we have. So you can use these kind of techniques in the front end as well. So you have one form which fill up the values and change the values, and you say, okay, give me the result, and that function will come here, grab the value, and then show you the result. So this is very handy. You need to practice a lot with classes. We've seen inheritance, we've seen getters and setters. So yeah, this is about the classes, guys, and I'll see you guys in the next section of the course with a lot more ES6 related to promises and callback functions and all that stuff. So you know, our content is never gonna stop. So yeah, just make sure to stick around, and I'll see you guys in the next section. Welcome back, everybody. In this video, we are going to understand the concept in JavaScript called promises. Now, promises are a little bit confusing for developers who are in a learning curve, not very expert in JavaScript, or they are trying to switch from ES5 version to ES6 because promises were introduced in ES6. Now, what is a promise? Let me give you a real world example. For example, you have a younger brother and he needs to finish his homework. So what do? You go to him and you tell him that, okay, you have to finish your work, then I'll give you an ice cream. So what are you making here? You are making a promise in the real world, right? So you're telling your brother, look, you have to finish your work, then you will get an ice cream. So unless he finishes his work, he is not going to get ice cream. Similar in JavaScript promises, we have to tell a function, you have to finish this work, then go and perform that function. So that function will not go and perform the second function first unless that finishes the first function. So let's go and take a look at example in coding, and I can assure you will be able to explain promises to anybody. Alright, so let's go to WebStorm now, and I'm gonna start typing some code. So we're gonna start by typing let, I'm gonna say promise is equal to, first I'm gonna use a promise object. I'm gonna press dot here. So once I press dot, I get some suggestions from WebStorm saying these are all the methods available on the promise object. So resolve, all, prototype, raise, and reject. So the most important one here are resolve and reject. Now I've given you an example of your brother, and if he finishes his homework, that means he resolved his promise, then he's gonna get an ice cream. But what if he does not finish his homework, then he rejected that promise? So we need to say, okay, it was rejected, it was not resolved, so it was not fulfilled. So that means we have a reject function on that. So here if I say resolve, and I will just say, okay, hello, or maybe we can say brother cleaned or finished work. Well, it's a typo, but it's alright. And then after that, how do we use this promise now? So this is a promise object. I'm going to use that variable saying promise dot, and now once I press dot on a promise object, I have like four main functions. So then, right, catch, finally, symbol dot, toString tag. Now what is a then? Now let's just say I rephrase my statement. So I will go and tell my brother, okay, you will finish your homework, then I will give you an ice cream. So what it's then here, it's a condition. Okay, so similarly in JavaScript, then keyword is a condition. So if it's fulfilled, then do this. If it's rejected, then do this. All right, so we use the then keyword here. So I'm just going to then, and it takes an a callback function. So I'll just say, okay, I'm gonna use the ES6 arrow function syntax, and then I'm going to log to the console saying console.log and say promise fulfilled. All right, I'm gonna save the file and refresh the browser, and here we can see it's logging promise fulfilled. All right, So now let's take a look at another example, but this time we are going to build a promise. Let's start by defining our promise. So we're going to type a keyword let, and then I'll name my variable promise is equal to new promise. So we'll create a new instance from promise object, and this promise object is going to take two functions, resolve and reject. I'll use the WebStorm suggestion snippet, then I'll press enter and it automatically type that for me. Now inside the code block, I'm going to type a Boolean variable. So let, and I'm going to say finished work is equal to true. So now why am I writing this Boolean variable here? Because I'm going to ask my brother whether he has done his homework or not. So we need to check whether if it's true or false. So we have finished work. If he has finished the work, then that means it's true. So here, after defining that Boolean variable, I'm going to say if finished work is true. You can do that by typing is equal to sign. This is the equality, and then you can say true. But in JavaScript, that if you are defining a Boolean variable in an if condition, then it will automatically understand, okay, this is a Boolean, so yeah, we're trying to check whether it's true or false. So here we're checking if it's true, then get inside this and resolve the promise. So we just say resolve the promise. And if he hasn't finished his work, so we type the else block here and we say reject the promise. Right, now I'm going to go down and then we're going to use this promise. So we say my promise dot then, which I've already explained, then is a condition. Say, okay, if the promise is resolved, then do this, otherwise do this. Okay, then, and this is going to take a callback. So we just say, and inside the code block, I will type console.log and you can say, okay, homework finished. Yay. All right, let's just run this and let's see what we get. Let's refresh, and here we can see homework finished. Yay. All right, he's gonna get an ice cream. Okay, so if I make this false here and refresh the browser, and there we go, it says uncatch promise. So it's rejected, promise rejected. So we can cache that as well by typing dot catch, and it's going to take a callback, and we can say console.log, and we can say he did not finish his homework. All right, I'm going to save the file. Let's refresh the browser, and here it says he did not finish with work. So if I make it true, save it, and there you go, his work is finished. Yay. All right, so this is just the overview of how promises are built. But the main reason why we have promises is by retrieving the data from the servers. That's the thing, that's what we need to do. All right. So to demonstrate that, I'm actually going to remove the code, and here we want to define a function. So first of all, I'm going to start by defining a function which will return a new promise. So we type here a function get data, and I'm going to return a new promise from this. All right, and first thing what we need to do here, we need to pass in some parameters in the function as well. So we have a method for getting the data, and then we have a URL, where to get the data from. I know we haven't talked about Ajax yet, and this is just a little bit introduction to Ajax. We have a separate section for Ajax, and Ajax basically asynchronous JavaScript and XML, which basically a way to grab the data from the server without reloading the page. Okay, we'll talk about that, but just take a look at the promise here now. So here we will say resolve and reject, and resolve and reject. All right, so it's gonna take a callback, and in the code block we make a bit of space here. I'm gonna save the file. Alright, so here we are going to create an XML HTTP request object, which will help us to retrieve the data. Now, from where we are going to retrieve data, you probably noticed that I have this another tab open. I'm going to go back to the website. I'm just going to make it bigger for a second. And this website named jsonplaceholder.typecode.com. So it's the first online REST API for testing and prototyping. So basically it's an API which we can grab the data from, and this is the link for that. And here we have some examples. So say, okay, this is used jQuery here. So we haven't talked about jQuery. We don't want to touch about jQuery because jQuery is built on the top of a JavaScript, which is a library. It's pretty great. We will look at that maybe in the course. Well, we'll find out once this course is finished recording. I'll finish recording this course. All right, let's go to resources. Resources, we have some users and to-dos. Let's take a look at users. So users these are some users at JSON data, which I can grab from this URL. All right, so this is a URL I can use to grab this data, right? So I'm gonna just make my WebStorm bigger again. And here, first of all, let's go and create XML HTTP request object. So we just say, okay, let XHR, I'm gonna name it, is equal to XML HTTP request object. Now, in this object, we are going to use a couple of methods, first of all. So I say xhr.open the request, and here we want to tell it what method we want to use. So here we'll say method. So this method is coming from what we will pass into get data method. All right, this is the method. And then it's going to ask for what is the URL. So let's say URL is the URL. All right. Then I'll say xhr.onload, right, is equal to, we set it to function, and then inside that we need to check few things. We say if this dot status, and we can say greater than equal to 200. I know it might be confusing for you guys, but be patient. I will talk about Ajax later in the course. So here we say if status is greater than is equal to 200, and this dot status less than 300. All right, then we're gonna get inside and we want to say, okay, then resolve, and resolve will take xhr.response. All right, so what are the response we get from this xhr HTTP request? Then we want to resolve that. This is what it's going to get resolved. And if that's not resolved, then we just say reject, and then reject is going to have an object. So we can say, all right, so we say status, and I'm going to say this dot status. Give me the status for that rejection. What was the status? Why? Okay, it's a misspell here. Okay, then we have a status text. This dot status text. All right, and after that we're gonna get out from here and out from here as well. Now we have this onload method on XRH, which is an XML HTTP request. Now we want to grab the error as well. So for example, we have xhr.on error. So if there is an error, then we have another function, and that's going to basically reject the promise as well. All right, I'm going to copy and paste this here. So it's pretty much a similar thing. I'm going to just paste that here. So if there is an error on that, then it's going to return reject promise. Okay, it's going to reject that. Then after that, we are going to get out from here as well, and then we call this xhr.send. So we will send it, right? Save it and add a semicolon here as well. Oops, I typed L, semicolon here as well. Now let's go and use this function we just created. I'm just going to make it smaller so we could look at it properly. That's too small, and make a bit of space here, guys. All right, so we call get data, And the first thing we want to pass in a method. The method is a get in uppercase. All the letters are uppercase. Get method. And what is the URL for that? Now the URL is going to be this URL. I'm going to copy that and I'm going to paste that in a string. I'm going to save the file. And then what is going to happen? So let's say if I go back and refresh the page and I'll see nothing here. But if I will go and expand this and we look at the network tab, not a console, I can see there is a request went to JSON placeholder.typecode/user. I'm going to click on that, and here I get some data in the response. So there you go. So the response object is pretty much giving us some data from here. All right. Now we want to check this. Okay. So I'm going to go make my browser smaller again. We're going to use then keyword. So here I'm going to go next line and we'll type .then. Right. Once this is resolved, then go and run this function, whatever goes inside then, which is a callback function. So here we'll just say another function and use ES6 syntax, and I'm going to say console.log and say promise resolved. Let's refresh the browser and we should see promise resolved, right? Now, how do we get the data from it? Now we get the data from by passing a parameter in our callback function. So whatever is returned from a get data function, which is a promise, we can get that by typing a parameter inside of a then function, and then that will be passed into a callback function, which is a parameter name is data. So here I'm going to say, okay, well, let's just print out data from here. Let's just refresh the browser, and here we have successfully retrieved the data from this URL. How cool is that? Now, there's few things we need to understand here. For example, if I want to make my code a bit modular, then I can do this way. So I'm just going to remove this code, and I'm going to say a function print data, and that's it. And we need to create that function, right? So I'm going to say a function print data, and here we can give it a data parameter. So basically what's happening, it's just going to call this function. So the function is here and we have the parameter data. So whatever is the response returned from get data, it's going to push that into a callback function, which is a print data. And here we can say, okay, console.log and log the data. I'm going to save the file and refresh the browser. And here we can see we're getting the data back. The response data is in JSON format. I know we haven't talked about JSON yet. Basically, it stands for JavaScript Object Notation, and this format is used to fetch the data from the servers. Now we can use the method JSON parse on this data to convert that into a JavaScript object, so we could use it in our HTML or do something with it. We have a separate video for JSON, which will teach you everything about JSON. So here we're just going to show you a quick method. So we say JSON.parse, and we're going to parse the data, and then console.log it. Refresh the browser, and here I've got a breakpoint here. I'm just going to go run with it. I'm going to go to console here. And now here we can see that we have an array of objects, and which is now usable in our HTML. The next thing we're going to look at is loading data with fetch. Welcome back, everybody. In this video we are going to take a look at a new feature available in ES6 called fetch. And fetch is used to grab the data, and yeah, it's pretty cool. In the last video we used this get data function in which we return a promise which create an XML object, and we handle a lot of errors here, and there was a lot of code. Now we are going to use fetch to retrieve the same kind of data using this URL. So let's go, and I am going to comment this block of code. So That's been commented. And now we are just going to use fetch. So I'm just going to make a space here. And so we could look at it. All right. So now here we just simply type fetch, and we are going to type the URL from where we want to fetch the data. So here I'm going to fetch the same URL which we used for the last video. So here we have a JSON placeholder.typecode.com/users, right? So this returns this data. Now here this fetch takes a then, so I'll just say then console.log. I'm going to save the file and go back and refresh the browser, and here we can see we got some sort of response back. Now we have a response back from this URL. It's going to say something in the body, and we have headers here. Okay, redirect this status 200. Now we can add our logic here saying that if status is 200 or set of text is blah blah blah, if the type is cars. So, but we're not going to go into that because we have already seen how to add basically how to validate our response, so make sure we catch our errors and stuff like that. So now in this video we're just simply going to grab this response and convert that into JSON, whatever is returned from this request. So here I'm going to simply say get me response, and then we're going to go and add error function syntax. Now I don't have to have a parenthesis because it's one parameter, and I don't have to have a code block because it's going to be one line of code. So here I will say res.json, right? That's the function we're going to call. Now this is going to get changed again, and simply we're going to say console.log. Let's save it and let's see if we get the same sort of data which we got from this request. So here we can see we got the data back from this URL which has ID, name, and it's basically a JSON object because we use this res.json method on it, and it converted that data to a JSON. So here even if I say, let's say, okay, I'm just gonna not call it, I'm gonna refresh the browser and let's see what we get. Well, we didn't get anything because we didn't actually convert that response into JSON. So JSON method is pretty great. It just converts your response into a JSON. So if you gotta make sure that the response endpoint is a JSON data. Right, so that's about it. It's a pretty cool. You can use it to fetch the data, less code. So I see you guys in the next video. Welcome back. In this video, we are going to start our TypeScript adventure, and a little bit introduction to TypeScript is good. Now, the language consists of new syntax, keyword, and type annotation. As a programmer, the language will be the main component you will become familiar with. Understanding how to supply type information is an important foundation for other components, because the compiler and language service are most effective when they understand the complex structure used within your program. So the compiler performs the type erasure and code transformation that converts your TypeScript code into JavaScript, and it emits warning and errors if it detects problems, and can perform additional tasks such as combining the output into a single file, generating source map, and a lot more. So the next question we have, what problem does the TypeScript solve? Now, since its first beta release in 1995, JavaScript has spread like wildfire. Nearly every computer in the world has a JavaScript interpreter installed. Although it is perceived as a browser-based scripting language, and JavaScript has been running on a web server since inception and supported on Netscape Enterprise Server. And recently on Node, JavaScript can even be used to write native application on operating systems such as Windows 8, Windows 10, Firefox OS, and now JavaScript can be used to create a native mobile application on iOS and Android as well. So, because JavaScript has a C-like syntax and it looks similar to a great many programmers, this is one of the JavaScript's key strengths, but it also causes the number of surprises, especially in the following areas: prototypal, inheritance, equality and type juggling, management of modules, scope, and lack of types. And TypeScript solves or eases this problem in a number of ways. So we will look at all of these in details later in the course, but this is just a brief introduction why TypeScript is so important and what it does. Welcome back. Now in this video, we are going to start taking advantage of what TypeScript offers. So let's go and open WebStorm, as I mentioned in the first section of this course, that we're going to be using WebStorm as our IDE. So I have this project here, TypeScript, and inside that, we simply have this compiler option target set to ES6. And I have this index.html file, and that's pretty much it is. So now we created this project in VS Code. That is why we have this .vs Code folder. I'm just going to delete that as well. So we're going to talk about TypeScript types. So TypeScript is optionally a statical type. This means that the types are checked automatically to prevent accidental assignment of invalid values. It is possible to output of this by declaring dynamic variables. Static type checking reduces errors caused by accidental misuse of types. You can also create types to replace primitive types to prevent parameters ordering errors, as described in I think in the introduction chapter. So let's go and start writing some code and figure out what do we mean by type. So here, first of all, let's go and create a new TypeScript file. So I'll right click here and then click on TypeScript file. And I'll just say test.ts file. Just gonna make it bigger. And here we define a variable. So we'll just say radius, let's say is equal to 4. All right. Now here we have an option, because we're using ES6 version, it says use let instead of var. So we do that. We listen to our compiler. I'm just gonna make the size a bit smaller here. That's fine. Right. So now if I will change the radius to string hello. All right. Now I'm gonna hover over my cursor and it says type always is not assignable to type number. So what happening here? So when we declared a radius variable and we stored the value 4, which makes it a number type, right? So JavaScript automatically analyze that and just say that, okay, this is a number type. Now, after that, if I change the value of radius to a string type, TypeScript automatically checks that it is not assignable to a type number. So if I just say, okay, let me just change this always to 6, and now we will not have any error because we're having a same type. So type annotations, although the TypeScript language service and is expert at inferring types automatically, there are times when it isn't able to determine the type. There will always be times where you will wish to make a type explicitly, either for safety or readability. In other cases, you can use a type annotation to specify a type. For a variable, the type annotation comes after the identifier and it preceded by a colon. As you can see on the screen in the picture, the most verbose style is to add a type annotation and assign the value. Although this is the style shown in many examples in this course, well, in practice this is the least you will use. The second variation shows a type annotation with no value assignment. The type annotation here is required because TypeScript cannot infer the type when there is no value present. The final example is just like a plain JavaScript. A variable is declared and initialized on the same line. In TypeScript, the type of the variable is inferred from a value assigned. So To demonstrate the type annotation in code, we will have an example now. All right, so let's do the fun part now. So the fun part is always coding, so let's do it. Now, first of all, let's declare a variable. So we type let, and then the identifier, we'll just say name. And then we need to type colon and annotation type. So in this case, we are trying to store a string into a variable called name. So what we'll type, we'll start typing string. Now I'll type string, and I said is equal to, and first let's just do a string value for a name variable, and we'll type Steve, or I'll just say away's my name. Now I don't see any error. If I hover over my cursor onto the variable name, it gives me unused variable name, but it's not causing an error, so it's all good. But let's just say if I change the value to 4, and as you can see, WebStorm is smart enough and TypeScript compiler is smart enough to read this line of code and saying, okay, the value of 4 cannot be stored in a variable which is string type. So it's expecting a value, a string inside a name variable. So here causing an error. So let's just say if I change it back to, let's just say Mirza, and the error is gone. Now here we're going to talk a little bit about any type, but let's look at the type used to specify an annotation can be a primitive type. So here string is a primitive, right? If I say a number and I change this Mirza to 4, right? So it doesn't give me an error because the type is a primitive type, which is a number. So it can be a primitive type, and it can be an array type and a function signature, or any complex structure you want to represent, including names of classes and interfaces you create. So if you want to output a static type checking, you can use the special AnyType, which marks a variable type as dynamic. Let's take a look at the dynamic type demo. So here, if I change the type to any, and I'll say, okay, I want to have a value 5, no error. And if I change this to string, let's just say string, still no error. Even if I change this to an array, so we say always Mirza, and I type 4 numeric value, we type boolean value, right? And now still there is no error. But now if I change any to string, it's going to give me an error. It gives me type string number boolean because we have a 3 type of data inside an array. So number is there, boolean is there, and a string is there. So it says it's not assignable to type string because it's an array. So if I type here array, the error will go away because now we're defining that, okay, the number and the string and a boolean are inside an array, and we were setting this value, this array, to a type array, which is set to name array. All right, that makes sense, right? So now we take a look at some of the demo, and we try to create some variables and try to store some numbers in that. All right, so here, first of all, let's just say var, or we can start with the let, and I'll say, okay, a, and type, I'll give it a string, and I'll say, okay, maybe change this a to person. I'll say it's a string, is equal to, we name it Steve, right? Next variable we create, so say let, I'll say height, and we just say height in centimeters. And here I'll type, let's just say a number is equal to 182 blah blah blah, right? Let have a now an array, but here is the catch. So here I'll just say names, and here we'll type an array, or we can just simply define an array is equal to, we'll just say, okay, arrays, and then Mirza, and then Steve. You might be thinking why it's an array. I was supposed to type array. Okay, and then I have here, let's just say 4, and then here we have a profession, so it's a doctor, or whatever the values you want to put in there, right? Now, no error because we are storing an array into a type array. But now, what if I want to change this to a 4, right? Now, still an array, but what if I want to make sure that every value inside an array is a string, or is a number, or is an object, or is a Boolean value? So here, if I type string, and I'll just add this single square brackets, now it's giving me an error because it's saying, okay, the type string number is not assignable to type string array. The type string array number is not assignable, so it's causing a 3 error. So if I change this to inside a string, now the error is gone because all the values are in array or string. So here, if I change this to, let's just say, a number, now again, there's an error. So here, if I change this to 4, and I will remove all of these values, or maybe we can do one thing. We want to leave that as demo. So here we change string. We're just going to duplicate this line of code, and here I want to change this to a number. Okay, now it's going to cause an error because there is an error because there's no number in an array. So if I change this to 4, and I just remove all of the values, and here we say 5, 8, 7, and then we just remove all of these string values, and the error should go away. But the error is not gone because the variable name is the same. So here we just say num test, right? As you can see, it's gone. So now we can define a type of array as well by using annotation, so string or any primitive data type. So here we can say, okay, I want to have a Boolean array. So here there's an error, but if I go down, make a duplicate of this, and then we change this bool test, and then here I will change this to Boolean, and then I can't store a number, a string, or an array in that. So now I have to store true, false, false. As you can see, there is no errors. Alright guys, so this is about this video guys. In the next video, we're gonna take a look at type annotation for functions and object, and also I'm gonna introduce to you guys interfaces in TypeScript. Welcome back. Now, so far we've seen a type array, string, number, and Boolean. Now let's try discussing the basic types available in TypeScript. So first of all, let's go and discover a type tuple. So tuple allows you to express an array where the type of a fixed number of element is noun, but need not to be same. For example, you may want to represent a value as a pair of strings and a numbers or booleans. So you can define tuple type, and let's go and have a look how we can do that. So right now I'm gonna create a variable tuple test, and then I'm gonna define a type in an array. And here I'm gonna type string, and I want it to be a number, and I want it to be a Boolean. Right? Now we've defined a tuple type, and we can set that is equal to, and then we can define an array with the square brackets, and then here I'll say always Mirza, and then I'll say 4 as a tuple, and then we'll say true. Right? Now once all of these 3 values are in there, that means there is no error. So we have successfully defined a tuple. Now look at the order we defined the types. So here we defined string, we defined number, we defined Boolean. For example, if I add a 4 or let's just say 10 before I define a string, now let's say what error I get. So if I just hover over my cursor here, it says type a number string for true is not assignable to a type string, number, boolean, types of property 0 or incompatible. So what's happening here is this first type is a string, and then here in the value, the first type is not a string, it's a number. So you gotta make sure that the order you define in the tuple in the value that should match as well. The next type we're gonna discuss is enum. So enums are a special type borrowed from other languages such as C# or C++. Enums are available in Java as well, and they provide a solution to a problem for special numbers. An enum associates a human readable name for a specific number. Now let's start typing some code here, and then once we are done with that, then I'll just show you what it means. So I'll say enum, and I'll just say door stats. All right, now here we have open, we have closed, and we have a jar. Right, now here we've defined an enum called door stats to represent the state of a door. A valid values for this door state are open, closed, or a jar. Under the hood in compiled JavaScript, TypeScript will assign a numeric value to each of these human readable enum values. In this example, the door state dot open enum value will equate to a number value of 0. Likewise, the enum value of door state dot closed will equate to a numeric value of 1, and the door state dot ajar enum value will equate to a 2. So let's verify that. Now what I'm gonna do, I'm gonna try logging this enum value to the console. Now if you start typing console.log and we just say doorstat.open, this is gonna cause an error because TypeScript does not know what we're talking about here. What is a console? So instead of that, we are going to create a function which will help us to log a value into the console. So we'll just create a function log, and here I will type a val, but we're gonna type a value. So here we'll just say that could be any. So the value we pass into this function to log on a console can be any type, right? So here we'll just say, okay, console.log val, right? Now let's go, and first of all, we are going to compile this to a JavaScript file. So we go to the terminal, and here we type tsc, and then the name of the file, tst.ts. Press enter, and that file will be compiled to a plain JavaScript. Now in WebStorm, you find that the compiled JavaScript, if you see that file here, and this has an arrow, so I'm just gonna click on that, and there we go. So we have a compiled test.js file as well. So if I open that, now you can see the JavaScript code was compiled from TypeScript code to a JavaScript code. So we have pretty much everything here. And if you look at this enum, it converted that into a function and assigned the value to the first value to 0 and 1 and then 2. So if we can verify this, I'm just gonna close this, and I'm just gonna go back to test file, and here we will just type log, and I'll type doorstat.open, right? And save the file, we go to the console, we compile this file, and then we go to test.js file, and here I'm just gonna run that, because here you can see we call the log function, we call this doorstat.open, and here I'm gonna type node test.js, and there you go, we get the result 0 here. So that means the enum is getting compiled to a plain JavaScript, convert that into this function, and then we can call that. There may be scenarios where you want to access the string representation of enum. So right now I'm accessing .stats.open, which gives us 0. But if I just use an array syntax and I type 0 here, and I'll just save the file. Right now we are compiling TypeScript file in a watch mode, which I've already explained to you guys in the first section of this course. So we go to the local one terminal. I'm just gonna clear it out, right? And then here we'll just type node test.js file, and right now we're getting open. So if I go to test.js file, now as you can see we're logging the value 0. The next type we're gonna look at is void. Void is a little like opposite of any, the absence of having any type at all. So you may commonly use this as a return type of a function that do not return a value. Let's take a look at the demo. Now I'm going to type a function. So we just remove this line of code and I'm going to start with a function, and we can say, okay, well, tell name, or maybe tell joke. All right. Now this function is supposed to return a string value. So here inside that I will go and say return string. Now here inside a code block, now if I say return this is a joke, right? Now it's not giving us an error. So if I just go log and I'll say tell joke, and then we just run this file, and here we see this is a joke that's get printed here. Now let's say that I will return a value 5. Now there is an error. So it says type 4 is not assignable to type string. So here we want to say that, okay, I want to return a number. Now we will talk about these functions in the next video, but just to show you guys that if we don't want to return anything like we do have in a log function, we can simply say, okay, I'm going to type a return type void. This is basically telling the function that we don't expect anything to be returned from this function. Welcome back. In this video we're going to talk about some advanced types available in TypeScript. So TypeScript also has some advanced language features that can be used when working with basic types and objects. In this video we're going to take a look at these advanced type features, which includes union types, type guards, type aliases, null and undefined, object arrest, and a spread. Now first, let's take a look at a union type. So I'm going to type here. So what is a union types? TypeScript allows to express a type as a combination of two or more than one type. This technique is known as union types and uses the pipe symbol. Now let's start typing some code here. So I will just create a variable and I'll name it union type, and I will set the type to string. And also I can say, okay, it can be a string or it can be a number. So I'll just say pipe symbol and a number. Now if I define union type is equal to, I'll say 1, and that doesn't give us any error. If I say union type is equal to, and I'll say hello, now it still doesn't give us any error. Now if I type a union type is equal to true, and now you notice that we are getting an error. It says the type true is not assignable to type string or a number. So this is how we can define a multiple types to a variable. Next, we're going to talk about type guards. I'm actually going to remove this line of code, and now here we'll type guards. So when working with union types, the compiler will still apply its strong type rules to ensure that we're not mixing and matching over types. Let's take a look at an example of a type guards. I'm going to paste the code So this is the code. Here we're defining a function named add_with_union, which accepts two parameters and return their sum. The arg1 and arg2 arguments are union types and can therefore be either a string or a number. Compiling this code, however, will generate the following error. So I did compile before, so I'll just clear it out and I'll say tsc types.ts. And now in here you can see we get an error. It says operator plus cannot be applied to type string number or string number. So what the compiler is telling us here is that within the body of a function, it cannot tell what type arg1 is. Is it a string or is it a number? This is where type guards come in. A type guard is an expression that performs a check on our type, and that then guarantees that type within its scope. Now consider the following code. So what we'll do is, we first of all, let's just remove the return statement, and here I'm going to go to the next line and I'm going to type, I'm just going to make it smaller so we could see it. I'm pretty sure this is fine. You guys can look at it. So here I want to type colon, string, and pipe, and a number, right? And then after that, we will go inside. And here, first of all, let's just do return arg1.toString plus arg2.toString, right? And error goes away. Now, type guards is an expression that we just talked about, which I'm going to paste it here. Also, let's modify the function name, and I'm going to say add with type guard. All right, let me explain this function to you guys now. Okay, so here we have a function named add with type guard that takes two arguments and is using a union type syntax to indicate that arg1 and arg2 can either be a string or a number. So within the body of the code here, we have two if statements. The first if statement checks if the type of arg1 is a string, and if it is a string, then the type of arg1 is treated as a string. And the second if statement checks if the both arg1 and arg2 are type number. Within the body of the second if statement, both arg1 and arg2 are treated as numbers. So the two if statements are our two type guards. Note that our final return statement is calling toString function on arg1 and arg2. So all the basic JavaScript types have a toString function by default. So we are in effect treating both arguments as strings and returning the results. Alright, so the next topic we're going to cover in this video is the type aliases. Sometimes when using unit types, it can be difficult to remember what types are allowed. To cater for this, TypeScript introduces the concept of a type alias, where we can create a special named type for a type union. A type alias is therefore a convenient naming convention for union types. Now let's take a look at an example. For example, I will copy this line of code, or maybe I will write the new code actually. Okay, so let's come down here and I will start typing a keyword type. And then I'll simply say, okay, it's either a string or a number. And I'll set that equal to string, pipe symbol, and a number, right? So we have our keyword type, a name of our type, and then we set that whether it's a string or a number. So now, instead of writing string or and a number with the pipe symbol between them, we can simply use this string or a number type. Let's take a look at an example. So we say function and we'll say add with alias. Okay, and then here in the function I will add two arguments, so arg1, and we set that is equal to string or a number, arg2, and then I can specify here it can be string or a number. So writing this is much more easier to writing this with the pipe symbol and string and number again and again. So instead of doing that, we can simply create a type here, and then simply we go down, and then we can just type a string or a number in the function or in a variable type. And we can say, okay, return arg1.toString plus arg2.toString. All right. So now you get the idea that what are the type aliases and what are the benefits of creating a type aliases. It could be a constant file which has all the types you can be used in your application, and you can just call from there and you can use it. So it saves a lot of time, saves a lot of typing, and it's pretty good. The next topic we will have in this video is going to be null and undefined. So let me just say null and undefined. Okay, so next we are going to create some space here. I'm going to make it a bit bigger so we can easily look at it. Okay, so in JavaScript, if a variable has been declared but not assigned a value, then querying its value will return undefined. JavaScript also includes the keyword null in order to distinguish between cases where a variable is known but has no value, and where it has not been defined, its current scope is undefined. So let's start typing a code here and we'll see what's going on here. So I'll say function, and I'll say test undef, and we can just simply say test inside that. And we'll just say console.log, and I'll say test parameter, and then here we'll just concatenate it with test. Right now let's call this function. So we'll say test undef, and we'll just leave it blank for, and we'll say test undef, and here we'll just say null. Right now, here we've defined a function named test undef, which takes a single argument named test. Within this function, we're simply logging the value to the console, and we'll then call it two different ways. The first call, which is here, it's a function does not have any arguments. This is in fact calling the function without knowing or without caring which arguments it needs. JavaScript allows this sort of function calling syntax. In this case, the value of the test argument within this test undef function will be undefined and will output test parameter undefined. The second call to the undef function passes null as the first argument. This is basically saying that we are aware of the function needs an argument, but we choose to call it without a value. This will output the function will be test parameter null. So TypeScript has included two keywords for these cases named null and undefined. Now let me just modify this function in TypeScript as follows. So here, first of all, the test, we can say that would be null and a number, right? And then the console.log, I can say test, and then we are going to, now here we've defined a test undef function to allow for the function to be called with either a number value or a null value. If we try to call this function in TypeScript without any arguments, as we did just before here, the TypeScript will generate an error. Let me show you what error it will generate. So we'll just clear the console, and I'll say tse types.ts. And now here we have expected one argument but got 0. Okay, clearly TypeScript compiler is ensuring that we call the test undef function with either a number or a null. It will not allow us to call it without any argument. This ability to specify a function that can be called with a null value allow us to ensure that the correct use of our function is known as compile time. Welcome back. Now in this video, I have created a new file called functions.ts because we're gonna start talking about functions in this video. So far we have seen how to add type annotation to a variable and have also seen how this syntax is easily extended to a function parameters. There are, however, a few more typing rules that TypeScript uses when it comes to functions. So, functions return types. Using a very simple syntactical sugar TypeScript syntax, we can also define the type of a variable that a function should return. In other words, when we call a function, it returns a value, and the return value should be treated as following. So let's start typing a code and see what we get. For example, if I type function and I say add numbers and A, and we just say it's a number, B parameter, and we can say it's a number as well. And then after that, after the parentheses, we just simply go and return, and I'll just say A plus B, right? Now here we're not actually defining what type of value should be returned from a function. Now here, if I type colon inside string, so here we have added a number type to the both of the parameters of add number functions A and B. And we also added a string type just after the braces. Placing a type annotation after the function definition means that we are defining the return type of an entire function. So in our code, then the function will return the type of a string. But unfortunately, this code will generate an error message as follows. If I take my cursor here, it says type number is not assignable to type string. So what this error message is telling us that the return type of add number function must be a string. Unfortunately, the function itself is returning a number and not a string. Hence the error. Taking a closer look at the code, we note that offending code is in fact returning A plus B, as A and a B are numbers. So we're returning the result of adding two numbers, which is of type number. So to fix the code, we need to ensure that the function returns a string. Now what we can do here, we can basically wrap this in parentheses, and then we can call a function dot to string, and that should fix the problem. Now this code will compile fine, and then it will return the addition of A and B in a string form. Now let's take a look at anonymous functions. So the JavaScript language also has the concept of anonymous functions, and they're the functions that are defined on the fly and don't specify a function name. So now let's write anonymous function. So I'll say var add, let's just say add string is equal to, we say function, and we'll say A, which is a string type, and then B, which is a string type as well. And then after that, we are going to return something from here. So we just say return A plus B. Right, now we haven't specified the return type, so we'll type here string. Right, now this code snippet defines a function that has no name and adds two values. Because the function does not have a name, it is known as an anonymous function. So this anonymous function is then assigned to a variable named add string. And the add string variable can then be invoked as a function with two parameters, and then return value will be the result of executing the anonymous function. So the output of this code will be A plus B. So if I use, let's just say we will create a function for logging. So I'll just say function log val, I'll define an any define type, and then inside that we just say return val. right? Or we can say console.log, or I need to actually define console.log val, and then here we type as wide, right? Now I'm gonna go and then just call this function log add string, and I'll say first one will be Awais, and then would be Mirza, right? And then after that, I'll just compile this code by tsc, and then I'll say functions.ts, that will be compiled, and then it's giving us an error, so argument of Awais is not assignable to parameter of a number. So what's happening here? Let's have a look. So we have add numbers. Oops, we're supposed to call a function add string, not a number. So I'll just save it and then try compiling it again, and it will compile, and then inside terminal we say node function.js, and there you go, we get back Awais Mirza. So while we're playing with this example, you may notice that the TypeScript compiler can figure out the type if you have types on one side of the equation but not on other. So this is called contextual typing, a form of type inference that this helps cut down on the amount of effort to keep your program typed. So the TypeScript compiler will automatically figure out what type of data we are returning, and that will make it optional to define a type of a return value within a function. Now let's talk about optional and default parameters. In TypeScript, every parameter is assumed to be required by the function. This doesn't mean that it cannot be given null or undefined, but rather when the function is called, the compiler will check that the user has provided a value for each parameter. The compiler also assumes that these parameters are only parameters that will be passed to a function. Well, long story short, the number of arguments given to a function has to match the number of parameters the function expects. Now here, add string function or add number function. For example, if I will go and say, okay, I want to remove Mirza from here. Now I'll just define one parameter value for add string function. I'm trying to log that in. So it says expected 2 arguments but got 1. See how TypeScript is smart enough to tell us what we're doing wrong here. Now, to make these parameters optional, we can type this keyword question mark. Now, once we type this keyword question mark, this will tell the TypeScript compiler that we are going to define the value of this parameter optionally. So if I don't give you a value, then just ignore this parameter. So here, if I just say, okay, let's just give a name, and I'll just save the file and just let's compile this. And then we are going to, let's just compile this. And then we're going to run that with the Node.js. So right now we get Awais Mirza, right? But if I remove this Mirza, the second value, and save and compile this function.ts file and then run it, and there you go, we have Awais and we have undefined. Now let me introduce you this question mark syntax. So TypeScript introduces the question mark syntax to indicate optional parameters. This allows us to mimic the JavaScript calling syntax, where we can call the same function with some missing arguments. As an example of this code, this is a strongly typed version of original concat string JavaScript function that we were using previously, I think in the last video. So note the addition of question mark character in the syntax of a third parameters, second parameter b question mark colon string. This indicates that the second parameter is optional. Therefore, all of above code will compile cleanly except from the last line. The last line will generate an error. It says build supplied parameters do not match any signature of call target. So this error is generated because we are attempting to call a add string function with only single parameter, and our function definition through all queries at least 2 parameters. So we can define an optional parameter there. Now, one note with the optional parameters: any optional parameter must be the last parameter defined in the function definition. You can have as much optional parameter as you want, as long as non-optional parameters preceded the optional parameters. So for example, if I'll just say, okay, this has one parameter, I'll say C colon A, B, C, or sorry, string, right? Now, instead of this B, make it optional, I'll make this C an optional, right? And then here we have an extra comma here. Now, what's happening here? Now here, if I hover over B, it says a required parameter cannot follow an optional parameter. So that means the optional parameter must be the last parameters, and we can define as many as optional parameters. So if I say question mark, and we have only one parameter and 2 optional parameters. Alright, so that's about this video, guys. In the next video, we are going to talk about default parameters, REST parameters in functions in TypeScript. Welcome back. In this video, we're going to talk about default parameters in functions and a REST parameter in function. In TypeScript, we can also set a value that a parameter will be assigned if the user does not provide one, or if the user passes undefined in its place. They're called default initialized parameters. Now let's take a look at an example. I'm going to go to WebStorm and I'm just going to start creating a function. We'll create a simple function which will build a name. And I will name it first parameter, first name, and the type would be string. The second parameter will be last name and type would be a string. But now I'm going to set a default value to this parameter. So how do we do that? I'm going to press is equal to, which is an assignment operator, and I'm going to type the value of the last name. So here I'll just say Mirza, okay? And then we just finish off this function. Now, if I define the first name and the last name, the value would be first name and last name in the function. But if I don't define or don't pass in the last name value, Mirza would automatically be assigned to a last name parameter. Now here, what we can do, we can return and we can say simply first name plus and then last name. Okay. Now here we are causing an error because we need to concatenate it with the last name. I'm going to save the file, and then here we use the log function and we say build name, and first of all let's type the first value for the first name. So I'll type my name Awais, right? And I'll type the second name would be Jamil, right? And then I'm going to I'm going to just remove these characters. Right, I'm going to save the file and let's go and compile this. So we'll type tsc and then the name of the file functions.ts, and that would be compiled. There we go, we have functions.js. Now we can run that in a console. So here I'm going to say node and then we say functions.js. Press enter and there you go, I get the value Awais Jamil, right? Now if I remove this Jamil, now we're only passing the value for the first name for the first parameter. I'm going to save the file. Let's just say tsc functions.ts. Let's compile this file, and then after that let's type clear to clear the console, and then I'll type node functions.js. function.js, press enter, and now as you can see, Awais Mirza is the value we returned from this function. So this is how you can define a default parameter. So if we'll change this to number, and then here we'll just make it, let's just say 50. Let's save the file and let's just run it with tsc functions.ts, and I'll say -- watch. Now I'm going to compile this in a watch mode where any changes I make to this TypeScript file will automatically be compiled. And we open a new terminal by clicking on this plus button, and here I'll type node function.js. Right now, this time we're getting an error, and the error should be okay. So the command is not there. So what's going on? So we'll just say node functions.js, and there you go, we get Awais and 50. The reason why it caused an error because it couldn't find the function.js file. The file name is functions with s at last. So I typed function, that's why it caused an error. Right, so now we know how we can define a default parameter. So depending on the type of the parameter, you can set the default value for that. So if I type here boolean, and I'll say okay, true, right? And I'm gonna say okay, push it in false here. I'm gonna save the file, and then here we'll run it again, and now we get false. But if I remove this false and I save the file, and then I run it, and then I'll just see it will be true. There you go. So the default value will be printed here. So this is a default parameter in TypeScript. Now the next we're going to talk about is rest parameter. Now required, optional, and default parameters all have one thing in common. They talk about one parameter at a time. Sometimes you want to work with multiple parameters as a group, or you may want to know how many parameters a function will ultimately take. In JavaScript, you can work with arguments directly using arguments variable that is visible inside every function body. But in TypeScript, you can gather these arguments and together them into a variable. So I'm going to create a function. So first of all, let's just say a function, and we just say build person, right? And then here inside that, first of all, let's just say we'll say first name, let's give a typed string. Then let's type the rest parameter. Now the rest parameter is basically 3 dots. And then after that, we type the name of the parameter. So let's just say remaining names, right? And then the value of that would be string array, all right? And then we just finish the code, and now we just say return first name plus an empty string plus, and then we say remaining names, and we're gonna call a function on this. So we say, let's say join, right? And then we join this on an empty string. All right, now I'm gonna save this file, and then after that we're gonna use this. So let's just build a person. So I'll just say let person1 is equal to, and we just say a build person. Actually build person, but not build name. And then the first name would be, let's just say John, and then we can say remaining, we can pass in a few other names as well. So we'll just say okay, Steve, and I'm just gonna make it smaller so we can look at it, right? I'm gonna make this terminal go down a bit. And then after Steve, we can say, all right, let's just say Paul, let's just say Daniel, and then say James, right? And then after that, we just add a semicolon. Now we can use this log function and just say person1, right? We can log that in. Now here, I'm going to say, let's just compile this and run this now. I'm gonna just remove this log and let's just run it. So let's type clear and then type Node.js. And now as you can see, we have John, Steve, Paul, Daniel, and James. So REST parameters are treated as a boundless number of optional parameters. When passing arguments for a REST parameter, you can use as many as you want, and you can even pass none. The compiler will build an array of arguments passed in with the name given after 3 ellipses, allowing you to use it in a function. The ellipses are also used in the type of the function with the REST parameter. Welcome back. In this video, I'm going to give you a little bit of introduction about this section of the course. Now, we've already seen how TypeScript uses basic types and function signatures to bring strongly typed development experience to JavaScript. TypeScript also introduces object-oriented features that are similar to other languages, including interfaces, classes, and inheritance. These object-oriented languages construct are the part of ECMAS6 standard, and as such will be included in the future versions of JavaScript. TypeScript allows us therefore to use these new object-oriented features from upcoming JavaScript version in our code base. So in this section of the course, we will look at these object-oriented concepts, how they're used in TypeScript, and what benefits they bring to the JavaScript development experience. So we will be looking at interfaces, classes, class constructors, class modifiers, static functions and properties, and inheritance, abstract classes, JavaScript closures, and factory design patterns. So we'll be covering all of these features in this section of the course. Welcome back. In this video, we're going to talk about interfaces in TypeScript. An interface provides us with the mechanism to define what properties and methods an object must implement. Therefore, it's a way of defining a custom type. We have already explored the TypeScript syntax for strongly typing a variable to one of the basic types, such as string or number. Using this syntax, we can also strongly type a variable to be of an interface type. This means that the variable must have the same properties as described in the interface. Now, I know that might not make any sense. We'll look at the demo in a second. So if an object inherits to an interface, it is said that the object implements the interface. And interfaces are defined by using the keyword interface. Now let's start typing some code and define our first interface. Let's type interface keyword and then the name of the interface. So in this case, I'll type I complex type. Right, let's give it a weird name. Add a code block, and then here we'd say ID, which should be number type, and then we have name, which should be string type. Now we start with an interface named iComplexType, which has an ID and a name property. So the ID property is strongly typed to be a type number, and the name property is type string. So this interface definition can then be applied to a variable. Let's take a look at the demo. So here I'll say, let's complex type. Let's give it a name of complex type. And then here we say the type would be iComplexType, which is equal to an object. And the object should have ID. And ID is a number type, so we give it 1. And then we have a name. And then it must be a string, so I'll just type my name Awais. Alright, so now as you can see, TypeScript is not giving us an error. It's just saying that unused variable complex type. Now what we're doing here, we have defined a variable named complex type and have strongly typed it to be a type of iComplexType. We are then creating an object instance and assigning the value to an object property. Note that the iComplexType interface defines both an ID and a name property, and as such, both must be present. So if I remove one of these, then we're having an issue here. So it's saying the type ID number is not assignable to type I complex type. Property name is missing in the type. So that's correct. So we just press Control or Command Z on a Mac to bring that back. Let's look at optional properties. So interface definition may also include optional properties, similarly to the way that functions may have optional parameters. Not all properties of an interface may be required. Some exist under certain conditions or may not be there at all. So these optional properties are popular when creating patterns like option bags, where you pass an object to a function that only has a couple of properties filled in. So what we're going to do here, I'm going to add a question mark here after the property declaration. I'm going to add this question mark, after the name, and that makes this property an optional. So we've defined an interface named I optional properties. Actually, we didn't create a new one, but I complex type, which has an ID property of type number and an optional property called name now. That is a type of string. Note how the syntax for optional properties is similar to what we have seen for optional parameters in function definitions. In other words, the question mark character after the name property is used to specify that this property is optional. Now, we can therefore use this interface definition as follows. So here, if I would just remove name property, and as you can see, the TypeScript compiler is not giving us any errors because that name is an optional now. So interface are a compile time language feature of TypeScript, and the compiler does not generate any JavaScript code from interfaces that you include in your TypeScript project. Interfaces are only used by the compiler for type checking during the compilation step. So in terms of when we compile this, for example, if I say tsc, I'll say interfaces.ts, that file will get compiled, and then we will just open the JS version of this, and here you can see we don't have anything special in JavaScript file. It's just a JS file, but interfaces are used during the compilation step. Now, we will be sticking to a simple naming convention for the interfaces, which is used to prefix the interface name with the letter I. Using this naming scheme helps when dealing with the large projects where code is spread across multiple files. Seeing anything prefixed with I in your code helps you to distinguish it as an interface immediately. So you can, however, call your interface anything. Now, couple more things about interface. Now we have a read-only properties as well. So some properties should only be modifiable when an object is first created. You can specify this by putting read-only before the name of the property. For example, if I will go and create another interface, so let's just say create another interface by typing interface keyword, and we can just say point or use a capital P, and then here I'll say X, and then that would be a number, Y, that would be a number. But now let's go down and let's create let's just say P1, and then we want a type of point, and then here we want to have X, let's just say 2, and Y would be, let's just say 2 as well, right? Now we're not getting any errors. So after down the line, if I go P1 dot X and I set that equal to 4, now this is not causing an error. We can just log this as well. So I'm going to create a function right on the top which will help us to log the values. I'm just going to make it a bit smaller as well. That should be fine, and we can just bring up the terminal a bit right? That looks okay now. So if we can just make it a bit smaller, I'll just zoom in whenever we need it, right? I'm gonna clear the terminal. Now, first of all, let's create a function which will help us log. So function log, and then after that, we just say type is void, and then we can say console.log, and inside that we have a val set to any type, right? And then we just log the value, right? That will help us to log to the terminal. Now here, if I just go and log p1 and let's save it, let's just tsc and just compile this interfaces.ts, press enter, and that will be compiled, but I want to compile it with the watch flag. So I don't want to go and keep compiling this over and over again. If I make any changes, that should be there. So here, the next terminal, I will just clear it out, and I will say, well, node interfaces.js. Now it's giving us an error. It says interfaces. Yep, that's right. We don't have that class name, so don't have a file name. So we node interfaces.js. Now here we have an object printed out 4 and 2. So now if I change this to, let's just say 6 and save the file and just run that again, now I get x is equal to 6. Now let's say in some cases you don't want the x to be changed. The value of x should not be changed. So we can set that by defining a read-only property before the name of the property. So if I here type read-only, and now if I will go and save the file, and now it's saying that it's already causing an error. So it's saying cannot assign to x because it is a constant or a read-only property. So once you create an instance of that interface, after that you will not be able to change the value of an x because it becomes a read-only. So here I can say this is read-only property, and if I try to change the value of that, so I'll say p1.y is equal to, let's just say 7. Now it's giving us an error. It's saying, okay, cannot assign y because it is a constant or read-only property. Now it's saying cannot assign y because it is a constant or a read-only property. Now the easiest way to remember whether to use read-only or constant is to ask whether you're using it on a variable or a property. Variable use constant, whereas property use read-only. Welcome back. In this video, we're going to talk about classes in TypeScript. Traditionally, JavaScript uses functions and prototype-based inheritance to build up reusable components. And this may feel a bit awkward to programmers more comfortable with an object-oriented approach, where classes inherit functionality and objects are built in from these classes. Starting with ECMAScript 2015, also known as ES6, JavaScript programmers will be able to build their application using the object-oriented class-based approach. In TypeScript, we allow developers to use these techniques now and compile them down to a JavaScript that works across all major browsers and platforms without having to wait for the next version of JavaScript. Now let's take a look at a simple definition of a class. So for example, I will type a keyword, a class, and I'll type the name of the class, and I'll just say simple class. And then I add a code block, and inside the code block I can add properties to the class. It can be just a variable holding a data, it can be a function, it can be an array of data, it can be a function. Let's take a look at, we will type ID, and I'll just set its type to a number, and I'll show you how to define a function within a class. We'll just type, let's just say create a print function, and then here we'll just say void is a return type, so it's not gonna return anything. And then inside a code block we'll just say console.log, and inside that we use a backticks from ES6, and here I can simply say simple class dot print, and then we'll just say called, right? And then after that, let me just explain to you one more time what's happening here. So here we have used the class keyword to define a class named simple class, and we have defined this class to have a property named ID and a print function. The print function simply logs a message to the console, and we can then use this class as follows. For example, I will simply create an instance of the class. So I'll just say let, and I'll say my simple class is equal to new simple class, and then after that I'll just say my simple class dot print, right? And now I'm going to clear the console, and let me just bring it up a little bit so we can look at it. All right, I'm gonna just compile this class to a JavaScript. So we'll type tsc, and I'll say class.ts, and that will be compiled. Now if I look at the project browser, inside the class we have a class.js. Now we can run that. I will simply say node class.js, and once I do that, I get this message simple class.print.called. So here we say, and I'm going to say creating an instance of a class. Save it, and let's just do compilation for that class, and let's just run it again. And now this time we get clean an instance of a class. Now let's talk a little bit about class properties. Now in order to access the properties of a class from within a class, we need to use the this keyword. Let me just type it big. Okay, let's just say this keyword. Let me just make it bigger so you don't forget it. The this keyword is very important in JavaScript programming. So as an example of this, let's update our simple class definition and print out the value of ID property within the print function. So to do that, I'm actually going to make it a bit smaller, and here we will type something like this. All right, I'm going to use the backticks. I'll say simple class has ID colon, and we'll say $, add our curly braces, and I'll say this dot ID. All right, let's save it. And now our print function is now referencing the ID property of the class instance within the template string. $curly braces this ID, and whenever we are inside a class instance, we must use the this keyword in order to access any property or a function available on the class definition. Now we can set the ID property of the class instance and call the update print function. So let's do that as well. So here we have created an instance of this class, and I'll say my simple class dot print, and just before that I can update the property. So I'll just say my simple class dot ID is equal to, I would just say, let's just say this. Okay, and yeah, that's it. And I'm going to save the file. Let's open up the terminal, and inside the terminal I'm just going to clear out first, and let's just compile this class, and then let's just run it. Now as you can say, it says simple class has ID 1238. Now this is how you can access the properties of the class, create a class, and in the next video we talk about how we can implement interfaces within a class. Before we continue, let's take a look at a relationship between classes and interfaces. A class is the definition of an object, including its properties and functions. An interface is the definition of a custom type, also including its properties and functions. The only real difference is that the classes must implement functions and properties, whereas interfaces only describe them. This allows us to use interfaces to describe some common behaviors of a group of the class, and then write the code that will work with any of the other classes. So now let's consider this code which I'm going to type. Let's just start typing the code. First, let's define a class A, and that will have a print function, and we'll just say console.log, and we'll just say, okay, class A dot print. Okay, now we are going to define another class, and we'll say class B, and we can say print, right? And then console.log, and we can say with the backticks, and we say class B dot print. All right, so here we've defined class definition for two classes, class A and class B. Both of these classes just have a print function. Suppose that we wanted to write some code that did not really care what type of class we use. So all it cares about is whether the class has a print function. Instead of writing a complex class that needs to deal with instance of both class A and class B, we can easily create an interface describing the behavior we need. So let's do that after. So here we make a bit of space, and I'll just say interface, and I'll just say I print, and then here we'll just simply say print function. Okay, now, and then we also create a function here. We'll just say function print class, and I'll just say a colon I print, and we can say a dot print. Right, so here we've created an interface named iPrint to describe the attribute of an object that we need within the print class function. This interface has a single function named print. Therefore, any variable that is passed in as an argument to the print class function must itself have a function named print. Now, we can modify our class definition to ensure that both can be used by the print class function as follows. So we'll go on the top. I'm actually going to just copy or cut these and just paste them on the top here. And then after that, I'm just going to make it a bit smaller. That should be fine. Right, and then here we will just say implements. And we can say, okay, that's going to print implement iPrint. And then for the second class as well, we can say iPrint. Oops, we forgot implement keyword. I'll just say iPrint. Now, when we implementing iPrint to the both classes, and down there, we are going to create two instances of each class. Let's do that, okay? So we'll just say let class A is equal to new class A, right? Let class B is equal to new class B. Now let's go back to this function for a bit, and here we created a print class function. So this function has one argument, which is a type of this interface. Now this interface has a single function named print. Therefore, any variable that is passed in as an argument to the print class function must itself have a function named print. And also we modified our class's definition to ensure that they can be both used by the print class function. So our class definition now use implements keyword to implement iPrint interface. This allow to use both classes within the print class function. So, and after that, I'm just going to make it a bit smaller. Okay, so here we're creating an instance of a class A and a class B, and then calling the same print class function with both instances. Let's do that. So here, if I'll say class A dot print, okay, and that should print out this bit. So basically we because the print class function is written to accept any object that implements iPrint interface, it will work correctly with both classes type. Interface therefore or a way of describing a class behavior, interfaces can also be seen as a type of a contract that classes must implement if they are expected to provide certain behaviors. Welcome back. In this video, we're going to talk about class constructors. Classes can accept parameters during their initial construction. For example, you create a class definition and then you are going to create an instance of that. Now, during that time, you want to type some values to your class. So this allows to combine the creation of a class and setting its parameter into a single line of code. Now let's start defining a class first. So let's just say a class, and we'll just make it a bit smaller. Okay, a class, and we'll just say class with constructor. Okay, and then inside the class, I'll just say ID, and we can set the type to number, and we can set name, we can set the type to, let's just say string. And then we have a function, a constructor function. So a constructor function starts with the keyword constructor. Let me type that first and then I will explain to you guys. So let's just say constructor, we add a parenthesis and we give a variable, let's just say a parameter to this function. We can say ID, we can say number, and then we can say name would be a string. All right. And inside the constructor function, now remember in the last video I've said about a this keyword, use the this keyword to access the property of the class. So here if I type this dot ID, and I'll set that equal to underscore ID. Okay, and I'll set this dot name is equal to underscore name. Now this keyword always target the class property. Now we are creating a constructor function, and then we will just say, okay, this dot ID is equal to this ID and this name, which is getting passed through the constructor function. So let's go down and then let's create an instance of the class. So here, what we will do, we'll just say, okay, let's say let, and I'll say class with constructor is equal to new, I'll say class with constructor. Now if I will just leave that blank, now here the WebStorm or TypeScript compiler is giving me that, okay, I expect 2 arguments but got 0. So here if I start typing, let's just say, we'll just say ID, which is supposed to be a number type. So I'll just say 10, comma, and then we'll just say, okay, and in a string we just say, okay, this is going to be, let's just say apple class. Okay, now we've created the instance. Now I can do a console log for that class as well, but we will create a function which will basically create a function which will help us to print out this ID and name what we create from the constructor function. So I'll just say, okay, I'm just say get name, and I will just say equal to, and I will just say void, and then here I'll just say return this dot name, right? It's giving me an error. It says string is not accessible to a void. So we just have to do a string, all right? Return type. And now here, when I create the constructor, I will just simply call that function. So I'll just say class with constructor dot, and I'll just say get name function. Now this is not going to do anything, but we need to do a console.log, and then inside that we define this function. All right, I'm going to save the file. Let's go to the terminal. Let's clear it out. I'm going to make it bigger, and here first of all, let's just say tsc, and we'll say class constructor.ts. Let's compile that, and that's been compiled. And now we say node.class constructor.js, and there you go, and we get apple. Okay, so as you can see, we defined a function to get that name from the class. Alright, welcome back guys. In this video we're going to talk about class modifiers. As we discussed briefly in the opening chapter, TypeScript introduces the public and a private access modifiers to mark class variables and functions as either public or private. Additionally, we can also use the protective access modifier, which we'll discuss later. So a public class property can be accessed by any calling code. Now let's take a look at examples. We'll define a class. Oops, that's a bit long. We'll say class, and I'll say class with public property. All right. And then here we'll just say a public ID is a number. All right. Now let's create an instance of that class. We'll just say let and say public access is equal to new class with public property. Okay. And now if I say, okay, public access dot ID, and we can set that equal to, let's just say 20 maybe. And then after that, we can simply do a console.log and we can simply say public access. All right. I'm going to save the file. Let's go down. Let's clear the console and we're just going to compile it by typing tsc and the name of the class modifiers.ts. And then we'll just say node class modifiers.js. And here we can see we have a class public property ID set to 20. Now we were able to access the property within that class ID. So now what if we define the property as a private? So I'm going to change this to, let's just say a private. I'm going to save the file and let's just do a compile again. As we can see from the error message, TypeScript will not allow assignment ID property of the class outside the class itself, as we have marked it as private. Note that we are able to assign a value to an ID property from within a class, and we have done it in a constructor function. So the class functions are public by default, not specifying an access modifier. So if we don't define any access modifier, it will be default to public. Classes can also mark functions as properties as protected, but we will cover this keyword a little later in the course. The next thing we want to talk about is constructor access modifier. TypeScript also introduces a shorthand version of constructor function, allowing you to specify parameters with access modifier directly in the constructor. So I'm just gonna make it smaller and let's just make it public, and let's just get rid of an error. And now we're gonna define another class, and here I'm gonna make it bigger again, and here we define a class, and I'll say class with automatic properties. Okay, and then inside that we'll add a constructor function, and we'll just say public, and we say ID, and we set that to number. We make a private name, and then we set that to string. All right, I'm gonna save the file, and let's just create an instance of that class. We just say let my auto class is equal to new class with automatic. So we just type a few things. Hang on. Class with automatic properties, and here we define, let's just say number 1 for ID, and we can say a class name. Okay, now if we go and do a console.log and we say, okay, we're using a backticks, we can say my auto class ID, and we can say use a $sign and then pass in the variable which is ID from my class and .id. All right, and then after that we have another, let's just do another console.log, and with using a backticks we can say my auto class name, and that would be a $sign, and we can just say my auto class dot name. Okay, and that's not accessible, right? So what's happening here? So this code snippet defines a class name, class with automatic properties, and the constructor function uses two arguments, an ID of a type number and a name of a type string. Notice that, however, the access modifier public for ID and a private for a name. This shorthand automatically creates a public ID property on the class with automatic property class and a private name property. So the shorthand syntax is available only within the constructor functions. We then create a variable named autoClass and then assign a new instance of a class with automatic properties class to it. So once this class is instantiated, it automatically has two properties, an ID property of a type number, which is public, and a name property of a type string, which is private. Now compiling this code, it will produce a TypeScript compile error. So let's hover over here, and it says, okay, the name is a private and only accessible within the class. So as you can see that a name is a private property. So next we're going to talk about read-only properties. So read-only is simply if you go inside and add a property. For example, if we say, okay, let's just do a read only, and then we just say name, and then we say string. Now this property is only a read only. So down here, if I go and say public access dot name is equal to, let's just say I'll type my name always, and that will give me an error. It will say cannot assign to a name because it is a constant or a read-only property. So simply we can use this keyword read-only to make it a constant or just to make it a read-only. We cannot assign the value to it. So whatever you assign here, for example, is equal to always, that would be it. That's what it is. That's what we can do. We cannot reassign the value because it's only a read-only. So what's next? So now we can talk about class property accessor. I'm just gonna clean up a code a little bit first before we can talk about that next step. Let's just clean this code, and also let's just get rid of this as well. So now we talk about the class property accessor. So ECMAScript 5 introduces the concept of a property accessor. An accessor is simply a function that is called when a user of our class either sets a property or retrieves a property of the class. This means that we can detect when users of the class are either getting or setting a property, and this can be used as a trigger mechanism for other logics. So to use accessor, we create a pair of a get and a set function with the same function name. In order to access an internal property, this concept is best understood with some of this code which we're going to write now. So let me just get rid of, let's just say, get rid of this code, and we just make it bigger. I'm gonna just put the console down, and here we'll have this public ID name number. I'm gonna make it a private, and also I will say private name, and we'll just say string, and private, and we can say, okay, let's just say hobby, right? And we can say it's a string as well. All of them are private. So here we are going to create, or we are going to basically write a get and a set function for these, so we can basically access the properties of these outside this class and set the properties of these outside the class. So IntelliJ products such as WebStorm has a nice feature. So if I select them, right click, and I click on generate, and it will give me an option setters and getters, actually getters and setter. So if I click on that, it gives me this, okay, name, ID, and hobby is there. So if I just select all of them and click OK, it will generate these functions for me. So I'm just gonna make it smaller. As you can see, it actually generated on the top. We're gonna cut it, and we're just gonna paste them down here. So let's just make them bigger. All right, so here we have all the get ID and set ID for every single variable here. So now let's just assume that we are going to write it ourselves. It might be confusing for you to just see them appearing. Okay, so let me just write a get and set for the name here. So we just say get, and we can say name, okay, and we add a function, and then we just say the type of that, which is going to be string, and then here we just simply say return, this dot underscore name. And that's how we can get the name outside this class. It's private, but we can still access it. And now here we can say a set function, which we have, let's just say name, and then we will have a value, which is going to be the same type, string, and we can simply say here this dot underscore name is equal to a value. Now if I create an instance of this class outside, as you can see, we have specified a private ID, name, and hobby, but we will still be able to access them. So here we will say, okay, let class, let me just let class with private, okay, is equal to new, and we can say class with private. Let me check the name of the class. It's just, okay, public properties. Actually, we change this to private, and we type class with a private, let's just say class with a private property, okay. And now if we want to set the value to the name, then we can simply call this instance variable dot, and we can say name is equal to, I'll just say aways, right? And then we can do a console.log, and we can say class with the private dot name, right? And now let's just go and compile this code, and let's try it, run it. Let's clear the console, and here I'm going to type tsc, and I will type the class name, which is class modifier. All right, it's been compiled, and here these are not basically there. It says accesses are only available when targeting ECMAScript 5 or higher. So I'm just going to clear the console, and I'll just say node dot, and we will run our class modifiers.js, and there we go. I get a ways back. All right, so now we are able to set the values of a private property of the class, and we can get that by simply calling the instance and the property name. All right, so the last thing we want to talk about is a static function and a static property. A static function is a function that can be called on a class without having to create an instance of the class first. So these functions are almost global in their nature, but must be called by prefixing the function name with the class name. Now, what we can do here, first of all, let me just create it a static function, okay? So static underscore hobby is a static, okay? So I'm going to basically, instead of using this instance, I'm gonna remove this, and I'm gonna remove this line of code as well. Now let's say that we want to access this. So for example, it's a static keyword, and then the name of the variable, and then the type of that. So I can simply say class with a private property dot underscore hobby is equal to, and we can say, well, it's playing video games, right? And then if I just go and get that, so I haven't got a getter for this, but if I just simply say console.log, I'll say class with private property dot underscore hobby, and let's just do a compile for that. And then after that, once compile, we'll just go and run it. So I'm going to clear the console, and we'll just run this file. And here we get playing video games. So we created a static, so it is available to our applications. It's available without even creating an instance of the class property. All right, so similar to that, we can create a static function as well. So let me just come here and I'll say static, and I'll say print data, and I will just say, okay, we're going to print the data, and we will just say void, and then after that I will just say console.log, and I will simply say this dot id underscore id. Okay, well, we're not able to get that in the function because it's out of the scope, but simply we can just grab a hobby here because it's a static function. So I can call this let's just say underscore hobby. Let me just see what's the name. Print data. Yeah, that's right. So let's just do here, let's just delete this line. We'll just simply say class with private property dot print data. All right, and now if I just do compile, and then we'll just rerun this, clear the console, and then we're going to rerun it, and we get undefined. The reason why we get undefined is because we haven't set anything to this hobby property. We can set it here if you like. Just say this is the static property. Save the file, and let's just compile this thing again, and once it gets compiled, we will just run it, and this time we get this is a static property, okay, because we set the value for that before. All right, so this was about static functions and static properties, and that's about this for this video, guys. Welcome back. In this video we're going to talk about inheritance. So in TypeScript we can use common object-oriented pattern. One of the most fundamental patterns in class-based programming is being able to extend existing classes to create new ones using inheritance. Alright, so the first thing we're going to look at is interface inheritance. Let's start typing some code here. So we'll just say interface, and I'll say I base, and then here we'll just say ID set to number, okay? And after that, I'm just going to make it a bit smaller. Yeah, that's too big. I'm going to put the console down. And after that, here we'll type another interface. And I'll just say I derived from base. And I can say use the keyword extend. Extend keyword is used to extend this class. Basically inherit this interface. All right, and I'll say I base, and now we'll just say, okay, name is a string, okay, and now we will define a class, and then we will implement the second interface, which basically extended this interface. So let's take a look at that. We'll say class, oops, that's okay, class. I would say interface inheritance, all right, which implements, and I will say I derived from base, right? So here, as you can see, we're getting an error. It says, okay, so interface inheritance incorrectly implement interface I derived from there. So here we will have to do like this, ID, and we'll have to say number, and then we will have to add a string name variable. Now the error will go away. So let's take a look at what we've done here. So we start with an interface called iBase that defines an ID property of a type number. Our second interface definition, I derived from base, extend from iBase, and therefore automatically includes the ID property. And I derived from base interface then defines a name property of a type string, as the I derived from base interface inherits from iBase. It therefore actually has two properties, ID and a name. We then have a class definition named interface inheritance, which implements this I derived from base interface. So this class therefore must define both an ID and a name. property in order to successfully implement all the properties of derived from base interface. Although we have only shown properties in this example, so the same rules apply for the functions. So let's take a look at that now, the class inheritance. So basically, if I'll just go and create this another class, let me just remove this code, or we can create a new file. We go to terminal, I'll say touch, say class inheritance.ts. We go to the project browser and I will open this file. Okay, let me just close this file and make it bigger. Right, so here now we'll define a class. Oops, class with constructor. Write that. So class, and I'll name it base class. Okay, and I'll say implement base. All right. Now here we're not really actually importing that, but let's just work with that for now. All right, so we'll say ID number, okay, and then we have another class which again wrote this class with constructor. I don't know what was that, but all right. So derived from base, okay, and it extends base class, okay, and implements derived from base. That's a bit bigger. We'll just make it smaller. And then inside that, we need to basically have a name string. Okay, so let's take a look at the example now. So the first class named base class implements base interface, and as such is only required to define a property of ID of a type number, as we've seen on the class where we define these interfaces. Let me just open that up again, inheritance. Okay, now we're gonna open this vertically, and then we open this here. Okay, cool. So now we can see we have an interface IBase and ID is required. So if we implement this interface, we need to define an ID in the class. So the second class derived from base class inherits from the base class, and it uses the extend keyword, but also implements derived from base interface. So as base class already defines the ID property required in derived from base, the only other property that the derived from base class needs to implement is the name property. Therefore, we only need to include the definition of a name property in the derived from base class. So TypeScript does not support the concept of a multiple inheritance. Multiple inheritance means that a single class can be derived from multiple base classes. TypeScript supports only one or single inheritance, and therefore any class can have a single base class. A class can, however, implement multiple interfaces as we can actually type the code, but we can basically create a couple of more interfaces, and we can say, okay, implements this, and also we can say, what is this base? Okay, we can just use a comma here, and that will be basically implements derived from base, and then it implements base as well. So now it has to basically, if we just remove this, okay, now it should have two values, ID and numbers. If we remove this, that will give us an error. It will say, okay, the interface inheritance incorrectly implements interface derived from base. So proper name is missing. So we have to have that because we are using this base and derived from base interfaces. So we need to have this name property set to string. Okay. Okay, we have something to talk about. We have a keyword called super. So when using inheritance, both the base class and a derived class, which is in this case, this is the base class and this is the derived class. This is the most often seen with a class constructor. If a base class has a defined constructor, then derived class may need to call through the base class constructor and pass through some arguments. And this technique is called constructor overloading. In other words, the constructor of a derived class overloads or supersedes the constructor of the base class. So TypeScript includes a super keyword to enable calling a base class function with the same name. Now let's take a look at a code here. So I'm just going to remove this line of code and we're going to start from scratch. I'll define a class and I'll say base class with constructor, okay? And then inside that we have a private, we set ID to number, and we have a constructor, and we can say underscore ID number, and here we just say this dot ID is equal to underscore ID. All right, and then we have this as a base class. Now we create a class which is going to derive from this base class. Let's start by start class keyword, and I would say derived class with constructor. Okay, and now we're going to extend this base class. So we say extends base class with constructor, right? And then we add a code block, and inside that we have a private, let's just say name, we give it string, and then inside the constructor function we have to define ID number underscore number string. Okay, and then here we'll just say, okay, where this ID coming from. So let's just say we define a private name, but we want to grab this ID from the base class which we extended. So how do we do that? We'll simply use the keyword super, and we will say underscore ID. Okay, and then this dot name is equal to underscore number, or we should change that to name. Okay, this is what I wrote wrong, so it's supposed to be name. All right, cool. So now what we have done in this code snippet, let me give you a review. Okay, so in this code snippet we define a class named base class with constructor, and which holds a private ID property. Here you can see it holds a private ID property. Now this class has a constructor function that requires an underscore ID argument. Okay, here we have a constructor which requires, if we want to extend this class anywhere else, we need to define this underscore ID, which is because it's available in the constructor. So the constructor of a derived class with constructor takes an underscore ID argument as an underscore name argument. However, it needs to pass an incoming underscore ID argument through to the base class. This is where the super call comes in. The super keyword calls the function in the base class that has the same name as the function in a derived class. So the first line of the constructor function for derived class with constructor shows the call using the super keyword passing the ID argument it received through the base class constructor. Welcome back. In this video we're going to talk about protected class members. So when using inheritance, it is sometimes logical to mark certain functions and properties as accessible only within the class itself, or accessible to any class that is derived from it. Using the private keyword, however, will not work in this instance, as a private class members is hidden even from the derived classes. So TypeScript introduces the protected keyword for these situations. Let me give you a code example. So here I'll paste the code. So let's take a look at this code. We start with a class named class with protected, which has an ID property that is marked as protected, and a public function named getID. Our next class derived from protected inherits from class using protected and has a single constructor function. Note, within the constructor function that we're calling has this.id is equal to 0. In order to set protected ID property to 0, so again, a derived class has access to protected member variable. Now let's try to access this ID property outside of the class. So I'm going to start with just making a bit of space here, and we're going to create a variable, and we can say derived from protected is equal to new derived from protected, and then we say derived from protected dot id, let's just do it, is equal to 1, and we will just log on the console. So let's just say console.log, and we can simply say with the backticks, and I'm going to say get id returns, right? And then outside this we will simply say, okay, actually being a backticks, we can just use $sign and then curly braces, and I would say derived from protected dot get id. Now save the file, and now the task will already giving us an error, but here we create an instance of derived from protected class and attempt to assign a value to its protected id property. The compiler will generate the following error. So let me go and compile this. So here we'll go, okay, tsc, we'll just say protected class members.ts, and now it should generate an error. It says the file protected is not found. Okay, why is not found? Oh, I'm gonna ls and see. Okay, there is a file. So it's a tsc protected class.ts. Now it should generate an error. So it says error, property ID is protected and only accessible within the class. So this ID property is acting like a private property outside of the class using protected, but still allowed to access it within the class and any derived from it. Welcome back. In this video, we're going to talk about abstract classes. Another fundamental principle of object-oriented design is the concept of abstract classes. An abstract class is a definition of a class that cannot be instantiated. In other words, it is a class that is designed to be derived from. The abstract class is sometimes referred to as abstract base classes, are often used to provide a set of basic functionality or properties that are shared amongst a group of similar classes. They are similar to interfaces in that, well, they cannot be instantiated, but they can have a function implementation which interfaces cannot. Abstract classes are a technique that allow for code reuse amongst a group of similar classes, or you can call it a group of similar objects. Now let's start typing some code which gives us a better idea what I'm talking about here. So I'm going to paste the code here. Let me explain to you this code. We start with a class name employee that has an ID and a name property, as well as a function called print details. The next class is named manager, and it's very similar to employee class. It also has an ID and a name property, but has an extra property named employees, which is a list of employees that this manager looks after. There's a lot of code that is common to these two classes. Both have an ID and a name property, and both have a print detail function. Using an abstract class for both of these classes overcome this problem with the common properties and code. Let's rewrite these two classes and introduce the concept of abstract classes. Let's start by defining an abstract class. So I'll type abstract class and then the name of the class. So the abstract keyword makes this class an abstract class. And then we have a class keyword. And then here we'll type abstract employee. Alright, so let me explain to you what's happening here. Here we have defined an abstract class named abstract employee, which includes an ID and a name property, common to both managers and employees. We define what is known as abstract function. So, what is an abstract function? Well, using an abstract function means that any class that derives from this abstract class must implement this function. We then define a print detail function to log the details of this abstract employee to the console. Note here we are calling abstract function get details from within the abstract class. This means that our code in the print detail function will call the actual implementation of a function in the derived class. Alright, so here I have defined two more classes, and let me explain to you now. So our second class, I'm just gonna make it a bit bigger here. Right, so our second class named a new employee extend abstract employee class. As such, it must implement get detail function that has been marked as an abstract in a base class. So this get detail function returns a string representation of a new employee's ID and a name property. Next, we have a class named new manager that derives from new employee. This new manager class therefore also has an ID and a name property, but has an extra property named employee, because this class already derives from new employee and it does not necessarily need to define the function get details again. It could simply use the version of get details function that the new employee class provides. Note, however, that we have actually defined this get detail function within the new manager class. This function calls the base class get detail function via super keyword and then adds some extra information about it. So let's take a look at what happens when we create and use these classes. So here, let's go down and I'm going to define another variable, and I'm going to say employee is equal to new employee, right? And then we'll just say, okay, employee dot ID is equal to 1. And then we have employee dot name is equal to, let's just say, employee name. All right, and then we will just use, okay, let's call this method employee dot print details. Here we have created an instance of a new employee class named employee, set its ID and name property, and call the print detail function from the abstract class. Recall that abstract class will then call the implementation of a get detail function that we provided in the new employee class, and therefore the output would be funneled to the console. So let's just compile this and let's see the results. So here we'll just say TSC and we will type the name of the class, so abstract class, ABS track class, compile it, and then we'll try to run it. Okay, it says cannot find the name new employee. So we have created an instance of a new employee class named employee and set its ID and a name property and call the print detail function from the abstract class. Recall that abstract class will then call the implementation of the get details function that we provide in a new employee class, and therefore it outputs the following. Let me actually go and compile this. So we'll just simply say tsc abstract class.ts, and after that we will run this. So we'll just say node abstract class.js, and there we go. So we have ID set to 1 and name employee name. Now let's use our new manager class in a similar way. So I'll create a manager instance. So manager is equal to new manager. We'll just say manager.id is equal to 2, and we can say manager.name is equal to, let's just say, new manager, and we can say, okay, manager.employees, so employees is equal to new, we can call it array, and then we will just simply say manager.print details. All right, so here we've created an instance of a new manager class named a manager, and set its ID and a name property as before. So because this also has an array of employees, we are setting the employees property to a blank array. When we call the abstract class printDetail function on the last line, it will give us employee count to 0. So let's do that. So I'll just go and compile this again, and then we'll just run this, and console, we can see we have an ID2, name new manager, and employee count is set to 0. Alright, so let me explain a few things here. So the abstract class implementation of a printDetail function calls a getDetail function of the derived class. The new manager class also defines a getDetail function. The abstract class will call this function on the new manager instance. The getDetail functions on the new manager instance then calls through the base class implementation, that is the new employee instance of the getDetail function as seen in the code super.getDetails, and then it appends some information about its employee counts. Using abstract classes and inheritance allow us to write our code in a cleaner and more reusable way. Abstraction, inheritance, polymorphism, and encapsulation are the foundation of a good object-oriented design principle. As we've seen, the TypeScript language provides us the ability to incorporate each of these principles to help us write good, clean JavaScript code. Welcome back. In this video, we're going to talk about generics. Generic programming allows algorithms to be written in a way that allow the types to be specified later. This allows the type to be processed identically without sacrificing type safety or requiring a separate instance of algorithm to handle each type. It is possible to constrain the possible type used by the algorithm by specifying a type constraint. In TypeScript, it is possible to create generic functions including generic methods, generic interfaces, and generic classes. In languages like C# and Java, one of the main tools in the toolbox for creating reusable components is generics. That is being able to create a component that can work over a variety of types rather than on a single one. And this allows users to consume these components and use their own types. To start off, let's do a hello world of generic. We can name it identity function. So identity function will return back whatever is passed in. So you can think of this in a similar way of echo command. So we'll simply define a function, and I'll just say identity and then args. So we can set that type to number. We can return type is number as well, and then we can simply say return args, right? And also we can say, right, we can define an any type for argument and the return type. So we'll do that function identity1, say args any, and then return type would be any as well. And then here we'll simply say return args, right? Now what's happening here? Well, using any is certainly a generic in that it will cause the function to accept any and all types for the type of args. We actually are losing the information about what that type was when the function returns. So if we passed in a number, the only information we have is that any type could be returned. Instead, we need a way of capturing the type of argument in such a way that we can also use it to denote what is being returned. Alright, so now how do we define a function which is generic? Let's take a look at the syntax for that. I'm going to type a function, and I'll name our function identity, and then we open the angle brackets, type T inside, and then closing angle brackets. Inside the parentheses, we type arg as a parameter, and we can set the type to T. Let's talk about return type. We return the type T as well. Inside the function, we simply return arg. Alright, so now let's do a bit of explanation. We have now added a type variable T to identity function. The T allows us to capture the type the user provides. It could be number, a string, a boolean, an array. so that we can use the information later. Here we use t again as a return type. So on inspection, we can now see the same type is used for the argument and the return type. This allows to traffic that type information in one side of the function and out the other. We say that this version of identity function is generic as it works over a range of types. Unlike using any, it also just precise as first identity function that used numbers for arguments and return type. Alright, so we've defined the generic function, which is identity function. Now, how do we use it? We can use this in one way or a second way. So there are two ways to use this function. First of all, let's define a variable, and I can name it a is equal to, and I'll use the identity function, and I can pass in the value as a parameter. So I'll say my string. Now here we're using this identity function by using a type inferred. Basically, what are the type of the data you provide to this function that would become a type of that function. So here we can use this type inferred, but we can simply define, let's just say let b is equal to identity, and then we use the angle brackets and we'd say number, and then here if I type now my string, that will cause an error because it says that the argument of the type my string is not assignable to the parameter of type number. So here we can see we can define the type of a parameter. So here if I change this to string, the error will go away. If I change this to boolean, and here I need to define, let's just say true. Okay, now these are the ways that you can use generics. Welcome back. In this video, we're going to be looking at how we can define a generic interfaces and generic classes. So the syntax for defining an interface, which is going to be generic, is pretty straightforward. We start by simply writing a keyword interface and then the name of the interface, and I will name it generic interface, and then angle brackets, we type t inside, and then inside the interface we wrap our parameter arg into parentheses and type t, and then the return type would be t as well. So now this is how you define a simple interface. Now let's take a look at how we can define a generic class. A generic class has a similar shape to a generic interface. Generic classes have a generic type parameter list in angle brackets. So let's take a look at how we can define a generic class. We simply start by typing a keyword class, and then we simply say generic class, right? And then we use an angle brackets, type t as a type, and now inside the class we simply say 0 of value, and then we can set the type to what? Give it a guess. Well, with t. So whatever the user will create from this class defining the t type, that will become the type of a 0 value. And then here we can simply say add, and here I can define a function as well which will return a similar type. X, let's just say t type, y is a t type, right? And they will return a type t. Okay, see, this is how we can create a function within a class with a generic type, so every return value and the parameter of value will be type t. Welcome back, guys. In this video we are going to talk about enums in TypeScript. Now, enums are a special type from other languages such as C#, C++, and Java, and it provides a solution to a problem of a special numbers. An enum associates a human readable name for a specific number. Now let's start by defining an enum. So I'm just going to come down to the third line, and we simply start by typing enum keyword, and then the name of the enum we're going to define. So we'll just simply say door state, right? And now inside this enum I can say, okay, whether it's open or it's closed or it's ajar, right? I'm going to save the file. Now here we have defined an enum called a door state to represent the state of a door. valid values for this door state are open, closed, or ajar. Under the hood, TypeScript will assign a numeric value to each of these human readable enum values. So in this example, the door state.open enum value will equate to a numeric value of 0. Likewise, the enum value for door state.close will equate to a numeric value of 1, and the door state.ajar enum value will equate to 2. So let's take a look at how we would use these enum values. So for example, I've created an enum. I'm just going to make it a bit smaller, and then we will create a new instance of an enum. So I'll simply say let, and we just say open door is equal to, and we can simply use, because we're in the same class, so door state dot, and we can say open. Okay, and now we can simply console.log, and I'm gonna say, okay, with the backtick, so I'm gonna say open door is $, and then here we simply say open door. I'm gonna save the file. Let's go to the terminal, and here we'll compile this TypeScript file to a JavaScript file so we could run it. So here I'll type tsc, and I'll say enum.ts, and that will be compiled. Now we want to run this, so I'll type node enum.js. Right, so here we can see the door open is 0. So the value here we have is 0. Now similar to this, if I change this to, let's just say close or closed, save the file. Let's compile the code again, and then just run it. And there you go, we get door open is 1. Alright, so basically enums are a great way to store some special numbers in a human readable form. And in TypeScript, we simply type enum keyword and then the name of the enum we want to define, and that's about it. And then we can use it in our application. Welcome back. In this section of the course, we are going to take a look at modules in TypeScript in details. So starting with the ECMAScript 2015, JavaScript has a concept of modules. TypeScript shares this concept. Modules are executed within their own scope, not in a global scope. This means that the variable, a function, or classes declared in the modules are not visible outside the module unless they are explicitly exported using one of the export forms. So to consume a variable, function, a class, interface exported from a different module, it has to be imported using one of the import keyword. Modules are declarative. The relationship between modules are specified in terms of import and export at the file level. Module import one another using module loader. At runtime, the module loader is responsible for locating and executing all the dependency of a module before executing it. Well-known modules loaders used in JavaScript are CommonJS, module loader for Node.js, and require.js for web application. Well, in TypeScript, just as in ECMAScript 6, or you can say ECMAScript 2015, any file containing a top-level import or export is considered a module. So a file without any top-level import or export declaration is treated as a script, though whose content are available in the global scope. Now let's take a look at export keyword. Any declaration such as a variable, function, a class, or interface can be exported by adding the export keyword. Now let's take a look how we can export a class. So how do we define a class? So if I say, okay, class ABC, and inside that I will simply say A string, right, B string, right? And now if I want to export this class, so this class can be used outside this file, I'll have to define an export keyword before the class keyword. Now, the next step would be how we can import this ABC class from a different TypeScript file. Before we learn how to use the import keyword and how to use this class in another file, before we do that, I want to add a constructor function, and then we will add a private parameter, and I will name it A, and type would be string. Another private parameter, and I'll name it _B, and type would be string. And then inside the code block, we will just say simply this.a is equal to _a, this.b is equal to _b. So this is just to demonstrate when we create a new instance of this class from another file, we will have to type in these values. Now we can add a function here, but for now this is good enough to demonstrate how we can export a class and how we can import a class from another file. Now we're going to go to terminal, and I'm going to use a touch command, and I'll create another file. So I'll say import class.ts, press enter, and now we go to project, and here we'll find this class, import class.ts. I'm going to open that, and then I'm just going to close this file, and then it doesn't really open. There's a problem, so instead of doing that, I'm going to just remove this file and maybe create a file using a WebStorm. So I'll just use this TypeScript file and I'll say import. Okay, it says import, but that's fine. We open the file. Then we're gonna close the terminal, and I'm gonna just make a bit of space here. Now here I will use an import keyword. Now import keyword is basically just as simple as exporting from a module. Importing and exported declaration is done through using one of the import form. So I'll type import, and then I'll add curly braces. Here I'll type the ABC, and now as you can see, if I type ABC, WebStorm giving me an option that, okay, do you want to import this class? Because WebStorm is smart enough to analyze if there is any class exists in this folder, it will just give me a suggestion. And if I press enter here, and it will say, okay, import from double quotation /module. So we can see that this class was created in the modules. So if we go to module.ts, and here we have the class, right? So we can import that there. Now we can use this class, create a new instance of this class by using this ABC, because we have imported that. Now if I go back to modules and remove this export, that means we're not going to export this. Let's save this, and we go to import file, and here it gives me an option. It gives me actually an error. It says it's not a module. So the file module.ts is not a module. So we'll go back and we export. Oops, we're gonna go and say export this class, and now the arrow will be gone. Now we can create a new instance of that ABC class by just specifying a variable. So let my ABC is equal to new ABC, and then here we type in few values. So we'll just say ABC1, then _B would be ABC2, right? Now we created an instance of that class, we imported, we exported a module, we imported a module. So it's pretty simple. It's pretty simple. And that's about it for this video, guys. Welcome back. In this video, we're gonna talk a bit more about modules. Now in the last video, we've seen how we can export and import modules. Now in this video, there's a little bit more stuff that we need to talk about regarding modules. The first thing I would like to mention here is that you see we are importing ABC class from ./modules file, right? But if we want to rename that, we can do that by simply saying, okay, I want to import ABC as, let's just say CDF, all right? Now once I do that, down the line here you can see that the TypeScript gives me an option saying, okay, it cannot find ABC module. So if I type here CDF, and it does not cause any error because ABC has become CDF, I cannot directly target ABC. The next thing we're going to look at how about exporting multiple classes and importing multiple classes from a single module file. We go back to module.ts, and here I'm actually going to make a copy of this code and make it a bit smaller. Yep, that's fine. And then I'm going to paste it here, paste it again, and I'm going to rename some of them. So here we rename this CDF, I'll rename this to FGH, I'll rename this to, let's just say, okay, 1, 2, 3, right? So we have multiple classes in the module. Now, how do we import all of them? We go back to import class, and I'm going to just remove this line of code, and I'm going to remove this line of code as well. So first of all, we will use an asterisk symbol. So I will import everything by using asterisk symbol. I'll type import asterisk as mods from ./modules, right? Now I have written this line of code which basically says import everything. This asterisk says everything as mods. Well, we're gonna call all the classes mods, and we can use these mods basically to create a validator for that. Okay, so now we will go down and we will say, okay, let me create, my first, or my class 1 is equal to, I'll say new mods dot, and once I press dot, I can see all the modules available in that modules class. So I can create a new instance of ABC, and here I will have to type, okay, hello, and I'll say world, right? So as you can see, I can create as many instances I want by using mods. So here we'll say my class 2 is equal to new mods dot, and I will create this one, 1, 2, 3, and then inside that we need to type in a string value, actually 2 of them. So we have hello. So as you can see that we can import multiple classes from single module files. So here we basically just have to use this export keyword and then do and then just export them. And here you can see that we imported ABC, that becomes yellow, and we imported 1, 2, 3, actually created an instance of these, and that become yellow. Now another thing we can do here, I'm actually going to remove these ones, right? And also, as we can rename our imported modules, we can rename them from export. So I'm just going to remove this export, and I'm going to remove export here as well. And down here, I will simply use this export keyword, and I will use the curly braces. I'm just going to make it bigger. And here I will say ABC. Well, that will do the same thing. That will basically help us to export. Now, if I go to import, and here I can see I have the error here in 1, 2, 3 because it doesn't exist. It doesn't exist. The reason why it doesn't know if it exists or not, because we haven't exported that. So here, if I say, okay, export, and I will say, with the curly braces, I'll say 1, 2, 3. Okay, and that will make the error go away. So there you go, our error is gone now. Now another thing we can do, as I mentioned, we can rename our exported module by just typing as, well, we can say class 1, all right, and I can say as class 2. Okay, I'm going to save the file, and we go to the import.ts, and here we have errors for both of them. So now, because we exported them by using this as class 1, as class 2, so we can't use ABC and 1, 2, 3 anymore. So if I go to the import.ts file, I'll have to use, instead of ABC, I'll just class 1, and I will use class 2. All right, so there are a few other things that I would highly recommend you should go and read the documentation of modules in a TypeScript lang.org. Welcome back. In this video, we're going to talk about namespaces. When working with large projects, and particularly when working with external libraries, there may come a time when two classes and interfaces share the same name. This will obviously cause compilation error. TypeScript uses the concept of namespaces to cater for these situations. Now we're going to start by defining a namespace. We'll say namespace, it's a keyword, and I'll say, okay, first namespace, right? I'll have a class and I'll say not exported, okay? And we have another class, we will have export, and then we'll say class, and I'll say namespace class. We can have ID set to number. Now here we're defining a namespace using a namespace keyword and have called this namespace first namespace. A namespace declaration is similar to a class declaration in that it is scoped by the opening and closing braces. This namespace has two classes defined within it. These classes are named not exported and namespace class. When using namespaces, the class definition will not be visible outside of the namespace unless we specifically allow this using with the export keyword. To create classes that are defined within a namespace, we must reference the class using the full namespace name. Now let's take a look at how we would create an instance of these classes. So I'm just going to go down and make a bit of space here. First of all, let's use a let keyword. I will say first namespace is equal to new first namespace, right? Dot namespace class, right? Now let's create another one as well. We'll say not exported is equal to new first namespace dot not exported. I'm just going to use not exported. Right, so I'm going to use this class name and I'll type it here, and then we use a parenthesis, and then we had a semicolon. Now here we're creating an instance of a namespace class and an instance of a not exported class. So note how we use to full namespace in order to correctly reference these classes. That is a new first namespace dot namespace class, and as a class not exported has not used the export keyword, the last line of the code will generate a following error. So if I hover over, it says not exported does not exist on a type of first namespace. So we can now introduce a second namespace by using the export keyword. So we go to the code here. I'm just going to make it a bit smaller. I'll say, okay, namespace, second namespace, class, export, namespace class, and namespace string. So let's do that. I will go and make a bit of space here, guys, and make it a bit smaller so we can zoom in later. So I'll say namespace, and I'll say it's a second namespace, and then inside that we have an export keyword, a class, and say name space class, right? The same name what we defined in the first namespace. I'll say name is equal to string type. Let's save it, and now let's create an instance of that. So just go down here and I'll say let second namespace is equal to new second namespace dot namespace class, and that's it. So now this namespace also exports a class named namespace. On the last line of this code snippet, we are again creating an instance of this class using the full namespace name, that is a new second namespace dot namespace class. Using the same class name in this instance will not cause a compilation error, as each class prefixed by the namespace name, and it's seen by a computer as a separate class name. Welcome back. In this video, we're going to look at some advanced features of TypeScript. And in this video, I'm going to explain tsconfig.json file. So the presence of a tsconfig.json file in a directory indicates that the directory is the root of a TypeScript project. The tsconfig.json file specifies the root files and the compiler options required to compile the project. And a project is compiled in one of the following ways. let's create a tsconfig.json file. So I'm just going to right click here and go to file, and I'll say tsconfig.json. Press enter, and right now we don't have anything in our file, but we'll talk about it in a second. So we can compile our project using tsconfig.json file, but how? So let's say we invoke tsc with no input files, in which case the compiler searches for the tsconfig.json file starting in the current directory and continuing up to the parent directory chain. For example, if we have a couple of folders here and we have a tsconfig.json file and we try to compile a file within child folder, it will go up and look for the tsconfig.json file, and if it doesn't find it there, it will go to the parent folder and then the parent folder and so on. Now let's start by defining some configuration for a compiler. So I'm actually going to make a bit of space here and make it bigger. So we start with the object literal with empty curly braces, and here I'll define a property compiler option. And WebStorm is pretty great. It automatically writes the code for me. So in double quotation, you will write a key, and then we have a colon, and then the property value. So here inside of a compiler option, we can define what module we want to use. So I will say module, and then I can use ES6 module, CommonJS, AMD. So if you want to go and study more about it, I would highly recommend go and read the documentation on TypeScript website, which is typescriptlang.org. So we'll use module as CommonJS, and I'll explain to you a bit more about CommonJS. And after that, we can define the library we're going to use. So here we say, okay, use a lib, and here I'll say, okay, ES6. All right. Now what's happening here is that when we compile our TypeScript code, as we all know that browsers cannot run TypeScript directly on them, the code has to be compiled as a JavaScript plain code, and then it will be able to run on a browser. So when we define a library and set to ES6, our code will be compiled to ES6 version of JavaScript, and we can also define a different version of JavaScript as well. For example, we can define ES5. Now the code will be compiled from TypeScript to ES5 version, where we won't have let and const and arrow syntax functions and all that stuff, which provided by ES6. So we'll change that to ES6, and then we will have some other properties here, but I would highly recommend that for the whole list of these properties, make sure you visit the website typescriptlang.org. And also we can define some file properties as well. We can define some include and exclude properties here as well. So first of all, let me explain to you a bit more about the compiler option. So the compiler option property can be omitted, in which case the compiler's default are used. So if you don't define anything here, the compiler default are used. So we can see the full list of compiler options on typescriptlang.org. So the file properties, and we define a file property here. I'm going to type a comma here, we say files. And inside the files, we can set few properties. So we can say, okay, core.ts can be there. So we can use core.ts, all right? And other TypeScript files we can use here. Let me explain to you what type files property does. So file property takes a list of a relative or absolute file paths. The include and exclude properties takes the list of a globe-like file pattern, and the supported globes widgets are asterisk or question mark, double asterisk and slash. So asterisk matches 0 or more characters, question mark matches any one character, and double asterisk and slash recursively matches any subdirectory. And there are also a lot of configuration that we can do in tsconfig. So I would highly recommend a visit tsconfig configuration document or article on typescriptlang.org.